The Great Ice Age. Just saying those words feels like opening a door to a time when the Earth was wrapped in a frozen stillness, where massive glaciers carved their way across continents and life, against all odds, persisted in ways both brutal and beautiful. Welcome to Quiet Universe, where tonight, we'll be stepping into a world long gone but never forgotten. A time when survival wasn't just a challenge. It was a masterpiece of adaptation, ingenuity, and sheer will. But before we begin, take a moment to imagine this. Endless expanses of ice shimmering under pale sunlight, stretching as far as the eye can see. Herds of mammoths trudging through the frost, their thick, woolly coats rippling in the biting wind. Saber-toothed predators stalking their prey with ancient precision, and humans, our ancestors, gathered around flickering fires, crafting tools from bone and stone, gazing into the darkness of an uncertain future. This wasn't just a test of endurance. It was the crucible where the resilience of life itself was forged. Tonight, we'll uncover the stories hidden in the ice, the mysteries of how the Earth danced between glacial and interglacial periods, and the mind-bending questions about what caused this frozen age to begin and end. We'll dive deep into the science, the landscapes, the animals, and even the humans who walked this icy world. And for those of you wondering if anything from that frozen past still walks, swims, or flies among us today, well, you're in for some surprising revelations. So, settle in, let the quiet of the universe wrap around you, and let's explore a world where time itself seemed to freeze. Imagine a world where immense sheets of ice stretched across vast portions of the land, transforming landscapes into frozen deserts and shaping the planet in ways we can still see today. This was the Ice Age, a chapter in Earth's history marked by repeated cycles of glacial expansion and retreat. It wasn't just one singular event, but a series of periods over millions of years when global temperatures dropped significantly, causing the formation of glaciers that extended far beyond the poles. The most recent of these, known as the last glacial maximum, reached its peak around 20,000 years ago, though the broader period of colder climates, known as the Pleistocene epoch, began roughly 5 million years ago. For humans and animals living during this time, it wasn't just a scientific anomaly. It was survival in a world where nature's forces dictated every move. Early humans, for instance, found themselves adapting to unforgiving conditions, huddling around fires in caves or shelters they constructed to ward off the biting cold. They followed the migration patterns of animals like mammoths and bison, which provided food, clothing, and tools. These creatures, too, had evolved to endure the bitter chill, their thick fur and fatty reserves acting as armor against the harsh environment. Yet, even amidst such challenges, life persisted, reshaping itself to meet the demands of a frozen Earth. The Ice Age wasn't a time of unending frost. It ebbed and flowed. Glaciers advanced, swallowing forests and carving deep valleys into the Earth, only to retreat when the climate warmed slightly. This rhythm, dictated by changes in Earth's orbit, shifts in greenhouse gases, and other natural factors, created cycles of cold and warmer periods. In some places, massive ice sheets more than a mile thick stretched across continents, covering what is now North America, Europe, and parts of Asia. In others, vast grasslands emerged as seas of ice displaced water, dropping global sea levels and exposing land bridges like the one that connected Siberia to Alaska, allowing humans and animals to migrate to new territories. The effects of the Ice Age linger in the very fabric of our planet. The dramatic reshaping of the landscape during those times created features like fjords, glacial valleys, and the Great Lakes of North America. Even today, scientists studying these formations can trace the scars left behind by retreating glaciers, offering a glimpse into the raw power of nature. For humanity, the end of the most recent Ice Age around 12,000 years ago marked the beginning of a warmer, more stable climate. This shift allowed agriculture to take root and civilizations to flourish, forever altering the trajectory of human history. But in every mountain carved by glaciers and every fossil buried in frozen soil, the memory of those icy millennia remains. It was a time when Earth reminded all life of its fragility and resilience, leaving behind not just a changed planet, but a story of survival etched into its landscapes. Earth has seen several ice ages over its long and turbulent history, each a period when the planet's climate shifted dramatically, plunging much of the surface into a deep freeze. These weren't just moments of geological change. They were transformative eras that dictated how life evolved, where it thrived, and where it struggled to survive. Scientists believe there have been at least 5 major ice ages, with smaller glacial events occurring between them, each separated by long stretches of warmer climates. The story of these icy epochs is written not only in the layers of rock and ice, but also in the silent testimonies of fossils, landscapes, and the survival strategies of living creatures. The first ice age that we know of, the Huronian glaciation, happened billions of years ago, over 4 billion years in the past. It was a time when Earth was still young, its atmosphere just beginning to stabilize. Imagine a world completely alien to anything we know. A planet covered in ice, lifeless in many ways, but also laying the groundwork for what was to come. Even microscopic life, the tiny organisms that would eventually lead to more complex forms, struggled during this time. It's thought that this ice age might have been triggered by the rise of oxygen in the atmosphere, a byproduct of early photosynthetic organisms, which set off a chain reaction that cooled the planet. Fast forward hundreds of millions of years, and you come to another major ice age, the Cryogenian, which occurred around 720 to 635 million years ago. This was no ordinary cold spell. It's often referred to as Snowball Earth because some scientists believe the planet was almost entirely covered in ice, from the poles to the equator. If you can imagine it, life had to cling to existence in the thinnest cracks of habitability, possibly near volcanic vents or in small pockets of open water where the ice couldn't reach. It was a profound test of resilience, and yet, life emerged from it stronger and more diverse, paving the way for the Cambrian explosion, a burst of evolutionary activity that followed. The following ice ages, like the Andean-Saharan and the Karoo ice ages, were also immense but more localized in their effects. These occurred hundreds of millions of years ago during a time when Earth was inhabited by early plants, fish, and eventually the first land-dwelling creatures. The Karoo, which happened roughly 360 to 260 million years ago, saw glaciers creeping across what is now southern Africa, leaving their marks in rocks that still bear the scratches of that ancient ice. Imagine a world where plants had just begun to colonize land, and early amphibians waded through icy swamps, their survival hinging on adaptations we can only try to reconstruct. The most recent and perhaps most familiar ice age, the Pleistocene, began about 5 million years ago and shaped the world in ways that are deeply personal to humanity. It was during this period that our ancestors evolved, learned to use tools, control fire, and build communities, all while contending with an environment that was often brutally cold and unpredictable. The great ice sheets came and went, advancing and retreating like a heartbeat over thousands of years. For early humans, these changes dictated where they could live, what they could eat, and how they could protect themselves. The last glacial maximum, around 20,000 years ago, brought glaciers to their furthest extent, pushing human ingenuity to its limits. By the time the ice retreated for good, around 12,000 years ago, the stage was set for modern civilization to rise. When you think about it, the ice ages are not just geological events. They're part of the human story. They've shaped our evolution, our landscapes, and even our understanding of resilience. Each ice age left behind marks not only on the planet but on the life that endured it, reminding us of the delicate balance between survival and extinction. In many ways, the echoes of these frozen eras are still with us, written in the layers of our Earth and the DNA of the creatures, including us, who managed to endure them. The beginning of an ice age is not a single event but a slow unraveling, a convergence of forces that push the Earth into a colder state over tens of thousands, even millions of years. To understand it, you have to imagine the Earth as part of a grand cosmic dance, its orbit, tilt, and wobble subtly shifting over time. These changes, known as Milankovitch cycles, alter the amount and distribution of sunlight reaching the planet. Sometimes, these shifts lead to slightly cooler summers, especially in the northern hemisphere, where land masses dominate. When summers aren't warm enough to fully melt winter's snow, that snow builds up year after year, eventually forming massive glaciers. But that's only one piece of the story. Earth's atmosphere plays a critical role too. The delicate balance of greenhouse gases like carbon dioxide and methane acts like a thermostat. At certain times in the planet's history, volcanic eruptions, weathering of rocks, or changes in ocean circulation have drawn down levels of these gases, allowing more heat to escape into space. Picture the Earth slowly cooling, not drastically or dramatically, but steadily, as these changes unfold over millennia. The oceans, vast and powerful, also contribute. Shifts in currents can redistribute heat around the globe, plunging some areas into freezing temperatures while others remain relatively mild. When these factors align, a cooler orbital cycle, lower greenhouse gas concentrations, and oceanic changes, the planet crosses a threshold where ice begins to take hold. What makes this process so remarkable is how interconnected it is. A drop in temperature might start small, but as glaciers grow, they reflect more sunlight back into space, amplifying the cooling in what scientists call a feedback loop. And life itself, as strange as it seems, can also influence the onset of an ice age. During certain periods, like the ancient cryogenian glaciation, the emergence of vast forests or algae blooms in the oceans may have pulled large amounts of carbon dioxide out of the air, contributing to the cooling. Even the placement of continents matters. When land masses drift toward the poles, they allow ice sheets to grow more easily, and when mountain ranges rise, they alter wind patterns and encourage the cooling of large regions. Now imagine living through the early whispers of such a transformation. For the first humans, the signs of change would have been subtle at first. A cooler season here, a longer winter there. Over generations, the shift would become undeniable, as the familiar landscapes began to vanish under ice and the rhythms of life were rewritten by the creeping cold. Rivers and forests became frozen wastelands. Animals migrated or disappeared, forcing human groups to adapt or perish. It's not just a story of planetary physics or chemistry. It's a story of resilience, of life reacting to forces far beyond its control, finding ways to survive in a world that seemed to be turning against it. The Ice Age didn't begin with a bang or a sudden freeze. It was a slow and relentless journey into cold, driven by the intricate and fragile interplay of the Earth's orbit, atmosphere, oceans, and life itself. Every element of the planet worked together to create an environment where glaciers could dominate, and in doing so, reshape the very fabric of the Earth and the fate of the creatures that called it home. The duration of an ice age isn't something that can be neatly summed up, because the term refers not to a singular, frozen stretch of time, but to an era defined by cycles of freezing and thawing. The most recent ice age, for example, known as the Pleistocene, began about 2.5 million years ago and technically hasn't entirely ended. We're still in what geologists call an icehouse state, with ice sheets remaining at the poles, even though the intense glacial cycles have largely receded. Within that broader time frame, there were periods when the ice surged forward, covering massive swaths of the planet, and other periods when it retreated, giving way to warmer climates. These cycles could last tens of thousands of years each, driven by the rhythms of Earth's orbit and the delicate interplay of atmospheric and oceanic conditions. For those living during the height of the Ice Age, it would have felt like an eternity. Imagine being part of a community thousands of years ago, knowing nothing of planetary cycles or geological epochs, only that the winters were long and brutal, and the summers barely warm enough to coax a bit of life out of the frozen ground. Entire generations would have lived and died under a sky that seemed locked in a battle with the sun, where the seasons were harsh and unforgiving. Some of the glacial periods during the Ice Age lasted over 100,000 years, with the vast ice sheets creeping southward, reshaping the land beneath them. And then, slowly, almost imperceptibly, the ice would begin to retreat, taking tens of thousands of years to melt back to the poles. But the story isn't just about cold. Interspersed within the Ice Age were interglacial periods, warmer intervals when the ice pulled back, allowing forests to regrow, rivers to flow freely, and life to expand into regions that had been inhospitable for millennia. These warmer spells could last for tens of thousands of years, offering brief reprieves before the cold returned. The cycle of glaciers advancing and retreating was like the Earth breathing, slow, deep, and powerful, with each breath reshaping the world in profound ways. The last major glacial period, often referred to as the last glacial maximum, peaked around 20,000 years ago and began its slow retreat around 12,000 years ago, giving rise to the relatively warm and stable climate we experience today, known as the Holocene. For humanity, the Ice Age wasn't just a test of survival. It was an epoch that shaped us. The length of the Ice Age, spanning millions of years with its cycles of extreme cold and brief warmth, defined where early humans could live, what they could hunt, and how they could adapt. It's strange to think that, while the glaciers were advancing and retreating at a pace that seems unbearably slow to us now, life persisted, evolving in lockstep with the shifting climate. Over the course of this immense stretch of time, the Earth transformed again and again, carving out valleys, forming Great Lakes, and setting the stage for the landscapes we know today. The Ice Age lasted for what feels like an eternity in human terms, but in the scale of Earth's history, it was just one chapter in an ever-evolving story. The rhythm of the Ice Age was marked by a constant back and forth, a natural tug-of-war between glacial and interglacial periods. These phases were like the Earth shifting between two vastly different moods, each bringing its own challenges and opportunities to life on the planet. During glacial periods, the world was locked in a relentless freeze. Massive ice sheets crept across continents, swallowing forests and grasslands, grinding mountains into dust, and lowering sea levels as water became trapped in the expanding glaciers. For early humans, these times were harsh and unforgiving, with resources scarce and survival often a matter of moving with the animals they hunted, seeking refuge wherever it could be found. Life was nomadic and uncertain, dictated by the advancing cold. Interglacial periods, by contrast, were moments of reprieve, when the ice retreated and warmth returned. These were times when the Earth breathed out, when rivers flowed freely again, and landscapes transformed from icy wastelands into fertile grounds where life could flourish. Forests spread, animals roamed farther, and human groups could settle, experiment, and grow. These warmer phases often lasted tens of thousands of years, and for those living through them, it must have seemed as though the Earth had finally softened, offering a kinder, more forgiving environment. The contrast between these two states, glacial and interglacial, was stark, and yet they were part of the same larger cycle, driven by shifts in the Earth's orbit, tilt, and axial wobble that altered the distribution of sunlight across the planet. The difference between glacial and interglacial periods wasn't just about temperature or ice. It was about how the world functioned. In glacial times, sea levels dropped dramatically, exposing land bridges that allowed humans and animals to migrate to new continents. During interglacial periods, rising seas drowned these pathways, reshaping coastlines and isolating populations. Glaciers, when they advanced, reshaped the land beneath them, carving valleys and depositing massive amounts of debris. When they retreated, they left behind lakes, rivers, and fertile soil, ready to be reclaimed by life. For humans, the interglacial periods offered the stability needed to develop agriculture, build communities, and begin shaping the environment in ways that no other species had before. But these cycles weren't predictable or simple. They played out over tens of thousands of years, with glacial periods typically lasting longer and interglacial periods offering only brief intermissions in the cold. The transition from one to the other wasn't abrupt but slow, so gradual that it would have been imperceptible to those living through it. And yet, over time, the effects would become undeniable as ice sheets advanced or melted away, as animals migrated or disappeared, and as humans adapted to each new reality. Glacial and interglacial periods weren't just climatic shifts. They were the framework within which life unfolded, testing the resilience of species, shaping ecosystems, and even influencing the course of human evolution. They were two sides of the same coin, each inseparable from the other, both part of the intricate and ever-changing story of our planet. Milankovitch cycles are like the subtle choreography of the Earth's movements through space, a complex and elegant interplay of shifts in orbit, tilt, and wobble that dictate how sunlight reaches the planet. Named after Serbian scientist Milutin Milankovitch, who first worked out their influence, these cycles are thought to be one of the primary drivers behind the coming and going of ice ages. But they're not dramatic events. They're subtle changes that unfold over tens of thousands of years, gradually nudging the planet's climate in one direction or another. To understand their role in the Ice Age, you have to imagine the Earth as both a spinning top and a wandering traveler around the sun. Never perfectly steady, always slightly changing its path and orientation. One of these cycles is eccentricity, the shape of Earth's orbit around the sun. Over a period of about 100,000 years, the orbit shifts from being nearly circular to slightly elliptical and back again. When the orbit is more elongated, the difference between the closest and farthest points from the sun becomes more pronounced, subtly altering how much solar energy the planet receives throughout the year. Then there's axial tilt, or obliquity, which refers to the angle of the Earth's axis relative to its orbital plane. Over about 41,000 years, this tilt shifts between roughly 22 and 24.5 degrees. A greater tilt means more pronounced seasons, with hotter summers and colder winters, while a smaller tilt leads to milder seasonal contrasts, which can allow snow and ice to accumulate over time. Finally, there's precession, the wobble of Earth's axis, which completes a full cycle roughly every 26,000 years. This wobble determines which hemisphere faces the sun more directly during different times of the year, subtly altering the intensity of seasons. These cycles, working together, regulate the distribution and intensity of sunlight across the planet, particularly in the northern hemisphere, where large landmasses are more susceptible to glaciation. When the cycles align in a way that reduces summer warmth in northern latitudes, snow from the previous winter doesn't fully melt. Year after year, this snow builds up, eventually compressing into ice that forms massive glaciers. The reflective surface of ice and snow amplifies the cooling effect by bouncing more sunlight back into space, creating a feedback loop that pushes the planet deeper into a glacial period. On the flip side, when the cycles align to increase summer warmth, the ice sheets retreat, marking the start of an interglacial period. Milankovitch cycles alone don't create ice ages, but they act as a trigger, setting the stage for broader climate shifts. They interact with other factors, like greenhouse gas levels, ocean currents, and the positioning of continents, to determine the planet's overall climate state. Think of these cycles as the steady ticking of a clock, setting the rhythm, while the rest of the Earth's systems decide how intensely that rhythm is felt. For humans living in the midst of these shifts, the changes would have been imperceptible at first. A slightly longer winter here, a cooler summer there. But over thousands of years, the impact would become undeniable. The cycles of ice and warmth that define the Ice Age weren't random. They were the result of this intricate celestial dance, a reminder that even the vast, ancient forces shaping our planet are connected to the quiet, predictable rhythms of the cosmos. The changes in Earth's orbit and axial tilt were like the invisible hands steering the planet into the cold embrace of an ice age. These changes, though incredibly slow and subtle, had profound effects on the way sunlight was distributed across the Earth, particularly in the northern hemisphere where massive ice sheets formed and retreated. Earth's orbit isn't a perfect circle. It shifts over time, becoming more elliptical or more circular in a cycle called eccentricity that spans roughly 100,000 years. When the orbit becomes more elliptical, the distance between Earth and the Sun varies more significantly throughout the year. This affects the intensity of seasons. During times when Earth is farther from the Sun, the summers are cooler, allowing snow and ice to accumulate and persist from one year to the next. Over thousands of years, these small changes in summer warmth can make the difference between an ice-free landscape and a growing glacier. But Earth's orbit isn't acting alone. Its axial tilt, or obliquity, also plays a critical role in shaping the Ice Age. The Earth doesn't stand perfectly upright as it spins. Its axis is tilted at an angle, and that angle shifts between roughly 22 and 24.5 degrees over a cycle of about 41,000 years. This tilt determines how much sunlight reaches different parts of the planet during the year, particularly at higher latitudes. When the tilt is smaller, the seasons become less extreme. Winters aren't as cold, but more importantly, summers aren't as warm. Cooler summers in northern regions mean that winter's snow doesn't fully melt, and over time, that snow compacts into ice, forming glaciers. The glaciers grow slowly but steadily, reflecting more sunlight back into space, which reinforces the cooling and allows the ice to expand further. Adding to this complex dynamic is precession, the slow wobble of Earth's axis, which shifts over a cycle of roughly 26,000 years. Precession affects which hemisphere is tilted more directly toward the sun during specific times of the year. This shift influences the intensity and timing of seasons, further tipping the balance between ice accumulation and melting. For instance, if the northern hemisphere experiences cooler summers because of precession, it amplifies the conditions that lead to glacial expansion. These orbital and axial changes don't cause ice ages on their own, but act as a kind of celestial clock, determining the timing and rhythm of the glacial and interglacial periods. When the tilt, wobble, and orbit align in a way that reduces the intensity of summer sunlight in the northern hemisphere, it sets the stage for the planet to plunge into a glacial period. Conversely, when these factors shift to increase summer warmth, the glaciers retreat, and the Earth enters an interglacial period. These cycles unfold so gradually, over tens of thousands of years, that the changes would have been imperceptible to early humans living through them, but their cumulative effects were nothing short of transformative. They dictated the growth and retreat of massive ice sheets, reshaped landscapes, and set the stage for the evolution and migration of species, including our own. The interplay of Earth's orbit and axial tilt was like a quiet but relentless force, shaping the destiny of the planet over deep time. Greenhouse gases, like carbon dioxide and methane, were the invisible threads weaving through the story of the Ice Age, amplifying or dampening the shifts in climate that were set in motion by Earth's orbital cycles. These gases acted like the planet's thermostat, trapping heat in the atmosphere and keeping Earth warm enough to sustain life. But during an ice age, their levels would rise and fall in response to the changing environment, either reinforcing the cold grip of the glaciers or helping to pull the planet out of deep freeze. It's a relationship that played out over tens of thousands of years, subtle yet powerful, where even small changes in greenhouse gas concentrations had immense consequences. When the Earth's orbital shifts reduced sunlight in key areas, especially the northern hemisphere, ice began to accumulate. As glaciers advanced, they locked up more and more water from the oceans, causing sea levels to drop. This cooling also affected ecosystems, slowing the natural processes that release carbon dioxide into the atmosphere, like plant respiration and the decay of organic matter. At the same time, the colder oceans absorbed more carbon dioxide, acting like a massive sponge. The combined effect was a drop in atmospheric carbon dioxide levels, which only deepened the cooling. It was a feedback loop. The colder it got, the less carbon dioxide remained in the air, which in turn made the planet even colder, allowing the ice to spread further. But the role of greenhouse gases didn't end there. They also became a critical factor when the planet began to emerge from its icy grip. As orbital changes shifted again, allowing more sunlight to reach the Earth, the warming oceans began to release some of the carbon dioxide they had absorbed. Melting permafrost and ice sheets also released methane, another potent greenhouse gas. These gases trapped more heat in the atmosphere, amplifying the warming and accelerating the retreat of the glaciers. This positive feedback helped pull the Earth out of glacial periods and into interglacial phases, where temperatures stabilized at warmer levels for thousands of years. It wasn't just the quantity of greenhouse gases that mattered, but the delicate balance between their sources and sinks. Volcanic eruptions, for example, could inject bursts of carbon dioxide into the atmosphere, while weathering of rocks over millennia would slowly draw it back down. Even life itself played a role. Forests, algae, and microbes all participated in the great exchange of carbon between the land, oceans, and atmosphere. During glacial periods, when ice blanketed much of the land, these natural cycles were disrupted, tipping the balance toward lower greenhouse gas levels. During interglacial periods, as ice retreated, ecosystems revived, and the carbon cycle regained its complexity, contributing to higher levels of greenhouse gases and a warmer climate. For humans living through these changes, the impact of greenhouse gases was invisible but profound. They dictated the conditions under which people could survive, shaping the ecosystems that provided food, the landscapes that could be inhabited, and even the migration routes that early humans followed. Greenhouse gases weren't the cause of the Ice Age, but they were its partners, responding to and amplifying the slow, rhythmic shifts in the Earth's orbit and tilt. Without them, the Ice Age cycles would have been far less dramatic in the world we know today. Its landscapes, its climate, its history might have been unrecognizably different. They were the silent regulators, steering the Earth's climate through its icy and temperate phases, connecting the deep forces of geology and physics with the fragile, fleeting processes of life. Volcanic eruptions were like the Earth's sudden, fiery exclamations amidst the long, slow rhythm of the Ice Age. While the advance and retreat of glaciers were driven by the steady pull of orbital changes and greenhouse gases, volcanoes occasionally erupted with dramatic force, disrupting the delicate balance of the climate. These eruptions unleashed massive amounts of ash, gases, and aerosols into the atmosphere, which could have both cooling and warming effects, depending on the scale and composition of the eruption. For those living in the shadow of an erupting volcano, the immediate impacts would have been devastating. Darkened skies, barren landscapes, and the choking presence of ash. But the global consequences unfolded over years, decades, and even centuries, quietly altering the course of the Ice Age. When a massive eruption occurred, it often sent vast quantities of sulfur dioxide into the upper atmosphere, where it combined with water vapor to form reflective sulfate aerosols. These particles acted like tiny mirrors, scattering sunlight back into space and causing surface temperatures to drop. The cooling effect could be dramatic, especially if multiple eruptions occurred within a short period, creating what some scientists call volcanic winters. For early humans and animals, this cooling would have added to the already harsh conditions of glacial periods, making survival even more precarious. Crops, if they were being cultivated at the time, might have failed, and ecosystems would have struggled to adapt to the sudden drop in temperature. But volcanic eruptions didn't always contribute to the cold. Over longer timescales, the carbon dioxide released during eruptions could have a warming effect, adding to the greenhouse gases in the atmosphere. While a single eruption might not release enough carbon dioxide to make a noticeable difference, the cumulative effect of many eruptions over thousands of years could gradually tip the climate toward warming. This dual role, cooling in the short term and potentially warming in the long term, made volcanoes unpredictable players in the story of the Ice Age. Their impact depended on the scale of the eruption, the types of gases and particles released, and the state of the climate at the time. Volcanoes also played a role in shaping the landscapes of the Ice Age. Lava flows and ash deposits could alter rivers and valleys, creating barriers or new paths for glacial movement. In some cases, eruptions beneath ice sheets caused rapid melting, sending torrents of water rushing across the land, carving deep channels and reshaping ecosystems. For early humans, these changes could mean new challenges or opportunities. A fertile plain created by volcanic ash, for example, or a new route opened by a retreating glacier. Volcanic eruptions were destructive, but they also brought renewal, adding nutrients to the soil and setting the stage for future growth. In the grand narrative of the Ice Age, volcanic eruptions were like sudden plot twists, unexpected, disruptive, and sometimes transformative. They didn't drive the cycles of glaciation and interglaciation, but they added complexity and unpredictability to a world already in flux. For those living through these eruptions, the impact might have felt immediate and overwhelming, but in the vast timescales of the Ice Age, they were just fleeting moments, bursts of energy and chaos against the backdrop of slow, glacial change. Yet their fingerprints can still be seen today in the landforms they created and the layers of ash preserved in the Earth's sediments, silent witnesses to the fire and ice that shaped our planet. Ocean currents were the lifeblood of the Earth's climate system during the Ice Age, silently circulating heat and energy across the globe. They acted like a vast conveyor belt, redistributing warmth from the equator to the poles and helping to regulate the balance between ice and water. But during the Ice Age, as glaciers expanded and retreated, these currents were anything but stable. They shifted, slowed, and even stalled in response to the changing climate, playing a critical role in deepening the cold or ushering in periods of warming. For early humans and the ecosystems they depended on, the changes in ocean currents were invisible yet powerful, shaping the very landscapes they called home. One of the most significant players was the thermohaline circulation, also called the global conveyor belt. This system is driven by differences in temperature and salinity, with cold, salty water sinking in the polar regions and warmer water rising near the equator. During glacial periods, massive ice sheets locked up enormous amounts of fresh water, lowering sea levels and increasing the salinity of the oceans. This made the thermohaline circulation more efficient, drawing warm water away from the tropics and sending it toward the poles. Paradoxically, while this process helped sustain ice sheets in the north, it also kept parts of the southern hemisphere relatively warm by pulling heat southward. Ocean currents were never uniform. They created regional contrasts, freezing some areas while leaving others more temperate. But the system was fragile. When glaciers began to melt during interglacial periods, they released vast amounts of fresh water into the oceans. This sudden influx of fresh water disrupted the balance of salinity, weakening or even halting the thermohaline circulation. Without this conveyor belt transporting heat, the northern hemisphere grew colder, sometimes plunging regions back into near-glacial conditions. These disruptions could happen rapidly, within decades, creating sudden and dramatic climate shifts that left ecosystems scrambling to adapt. For people living near coastlines or dependent on marine resources, such changes could mean the difference between abundance and scarcity, survival and migration. Ocean currents also influence the distribution of nutrients, shaping the productivity of marine ecosystems. As cold water sank in polar regions, it pulled surface water down with it, drawing up nutrients from the deep ocean and other areas. These nutrients fuel blooms of plankton, which form the foundation of the marine food chain. During glacial periods, the shifting currents altered where and how these nutrients were distributed, sometimes creating rich fishing grounds and at other times leaving vast stretches of ocean barren. For early coastal communities, These changes could dictate where they settled, how they fished, and what they ate. The interplay between ocean currents and the Ice Age was a constant feedback loop. The growing ice sheets altered the salinity and temperature of the oceans, which in turn influenced the climate, driving the expansion or retreat of the ice. It was a system so interconnected that a small shift in one part of the world could send ripples across the entire planet. Ocean currents didn't just respond to the Ice Age, they helped shape it, determining the flow of heat and energy that kept the Earth's climate system in motion. For the people and animals living through these shifts, the oceans were both a source of life and an unpredictable force, quietly sculpting the planet beneath the surface of the water, far beyond the reach of human eyes. During the Ice Age, vast portions of Earth were transformed into frozen wildernesses, reshaping the planet's surface and testing the resilience of every living thing. Imagine a world where survival meant confronting the relentless grip of ice and snow, where entire regions were buried beneath towering glaciers that seemed to stretch endlessly into the horizon. Northern North America, including much of present-day Canada and parts of the United States, lay beneath an immense ice sheet called the Laurentide Ice Sheet. This sheet extended so far south that it covered areas now bustling with cities and life, including regions around the Great Lakes and the northeastern United States. Europe, too, bore the scars of this icy dominion, with the Scandinavian ice sheet spreading its frozen reach across much of northern Europe, engulfing lands that now flourish with forests, rivers, and towns. For the people of the time, our distant ancestors, this was a world of extremes. They navigated landscapes that seemed alien compared to today, with icy wastelands bordering pockets of tundra and steppe. In some places, the ice was kilometers thick, pressing down on the Earth's crust and reshaping its contours. Human groups were often forced to retreat to the peripheries of these icy realms, clinging to warmer regions where they could eke out an existence. Southern Europe, parts of Asia, and regions in the Americas offered refuge, with their milder climates providing conditions for life to persist. In these sanctuaries, people hunted mammoths and reindeer, gathering what they could to sustain themselves. Their survival was a delicate dance with the environment, adapting tools, clothing, and strategies to meet the harsh demands of the age. The Southern Hemisphere, too, bore its icy burdens. In South America, glaciers crept down from the Andes, carving valleys and shaping the landscape in ways that remain visible today. New Zealand's Southern Alps and parts of Antarctica were shrouded in ice, while areas closer to the equator retained their tropical character, serving as lifelines for countless species. The human populations in these regions lived a different rhythm, but they, too, felt the far-reaching effects of a cooler world, with changing rainfall patterns and ecosystems. Everywhere the ice advanced, it left behind traces of its immense power. Rivers of meltwater carved channels into the earth, forming features like the Mississippi River and the fjords of Scandinavia. As glaciers retreated, they deposited vast moraines and created new lakes, reshaping the world humans would eventually come to dominate. The people who lived through this time bore witness to these transformations, and their lives were shaped by the constant tension between the cold's encroachment and the pockets of warmth that sustained them. This was a world in flux, where humans stood as both participants and observers in a drama written by ice, stone, and time. It was a testament to adaptability, ingenuity, and the unyielding drive to survive in a landscape that demanded everything from those who dared to inhabit it. The immense weight and slow, deliberate movement of glaciers have left marks on the Earth's surface that tell a story of transformation. Picture a glacier, a river of ice, slow but unstoppable, pressing down on the land beneath it. Its weight alone compresses the ground, shaping valleys and flattening ridges, while its movement carves and scrapes like a sculptor working with unimaginable patience. These frozen giants didn't just reshape landscapes. They redefined how people interacted with their surroundings, forcing entire generations to adapt to the changes wrought by the ice. As a glacier advanced, it acted like a massive plow, scraping away soil, rocks, and vegetation, leaving bare, polished surfaces in its wake. Boulders the size of houses were lifted and carried, dropped miles from their origins when the ice finally receded. These erratics, as they're called, became landmarks, sometimes even objects of awe or reverence for early humans who wondered how such colossal stones came to rest where no mountain was near. Beneath the glacier, immense pressure and grinding turned bedrock into fine sediment called glacial flour, which rivers carried downstream. giving lakes and waterways their milky turquoise hues. For the people living in the shadows of these glaciers, the reshaping of the land meant adapting to entirely new environments. Glacial valleys, for instance, began as narrow, V-shaped canyons carved by rivers, but under the glacier's grinding power, they widened and deepened into the characteristic U-shape that defines them today. These valleys became fertile grounds for human settlement after the ice receded, their flat floors and nutrient-rich soils perfect for agriculture. Fjords, dramatic, steep-sided inlets flooded by the sea, were carved by glaciers, too, creating natural harbors that would later become hubs for trade and exploration. Moraines, the ridges of debris left behind at a glacier's edges, became part of the landscape that humans would later use for boundaries, paths, and even shelter. Kettle lakes, formed when blocks of ice broke off and melted into depressions in the ground, became sources of water and gathering points for wildlife, vital for survival. As the glaciers retreated, they left behind braided rivers and wetlands, creating habitats rich in resources for hunting and gathering. The ice's touch also shaped the Earth's weathered mountains, turning jagged peaks into smoother, rounded domes in some places while leaving sharp, craggy ridges elsewhere. For the people who came after, these glacial scars weren't just natural features, they were lifelines. Rivers born from glacial melt carved deep gorges and laid down fertile plains, where early farmers thrived. The great basins scoured by glaciers filled with water to become lakes, essential reservoirs that sustain life even now. The Great Lakes in North America, for instance, owe their existence to these ancient glaciers, as do countless other lakes scattered across the planet. The relationship between humans and the landscapes left by glaciers is one of awe and adaptation. Where glaciers tore at the earth, they also laid foundations for rivers, valleys, and lakes that have nourished generations. The marks they left behind are reminders of the sheer force of nature and the resilience of life that adapted, rebuilt, and thrived in the wake of their icy passage. The Ice Age wasn't just a time of cold and struggle. It was a master architect, reshaping the Earth into a landscape filled with striking features that would later define how humans settled, traveled, and thrived. When the glaciers advanced, they moved with an almost incomprehensible power, carving deep valleys, sculpting mountains, and leaving behind lakes and basins where none existed before. These changes weren't subtle. They rewrote the map of the world, turning the raw power of ice into landmarks that became central to human history. Fjords, for instance, are a testament to the ice's relentless force. These steep-sided inlets, now filled with seawater, were once valleys carved by glaciers grinding their way through ancient mountains. As the ice moved, it gouged the bedrock, creating deep troughs that became fjords when the glaciers melted and sea levels rose. For the people who came later, fjords weren't just beautiful. They were lifelines. They provided safe harbors for boats, access to rich fishing grounds, and natural corridors through otherwise rugged landscapes. The coastal communities of places like Norway, New Zealand, and Chile owe much of their culture and survival to these glacial creations. The Great Lakes of North America are another lasting legacy of the Ice Age. Imagine glaciers so vast and heavy that they scoured the earth, leaving behind immense depressions that filled with meltwater when the ice retreated. These lakes became vital sources of fresh water, supporting ecosystems and eventually human civilizations. They served as highways for trade, routes for exploration, and centers for settlements. Long before modern cities like Chicago and Toronto rose on their shores, indigenous peoples depended on the Great Lakes for fishing, transportation, and survival. Their lives intertwined with the bounty the ice had left behind. Other features, like drumlins and eskers, might seem less dramatic but tell equally fascinating stories. Drumlins, those smooth, elongated hills scattered across glacial plains, were shaped by the flow of ice, their orientation revealing the direction of the glacier's movement. For early settlers, these formations often became natural routes or vantage points, places to build villages or fortifications. Eskers, snaking ridges of sand and gravel left by rivers flowing beneath glaciers, became natural roads, easy to traverse in otherwise rough terrain. They're the kind of feature you might overlook until you realize how crucial they were for people moving across vast, empty lands. Kettle lakes and ponds, small but numerous, were born when chunks of ice broke off glaciers and melted into the ground, creating depressions that filled with water. These lakes became hubs of life, attracting animals and, in turn, humans. In regions where resources were scarce, such water sources were vital, serving as gathering spots and places to fish or hunt. Glacial outwash plains, sprawling expanses of sand and gravel deposited by meltwater, also shaped how humans interacted with the land. Even the mountains bear the mark of the Ice Age, with their jagged peaks and cirques, bowl-shaped depressions carved by glaciers, standing as reminders of the ice's passage. For people living in these regions, the rugged terrain became both a challenge and a source of opportunity, offering shelter, vantage points, and resources like fresh water from glacial melt. The features left by the Ice Age weren't just geological marvels. They were blueprints for human survival and progress. Every fjord, lake, and ridge bore the story of ice's power and the resilience of those who adapted to live among the remnants of that frozen world. The Ice Age shaped not just the land, but the path of humanity itself. During the Ice Age, the ice sheets spread like vast, frozen empires, covering an astonishing portion of the Earth's surface and transforming the planet into something almost unrecognizable to modern eyes. Imagine standing on the edge of one of these ice sheets, an expanse of shimmering white stretching endlessly, its sheer scale overwhelming. These glaciers weren't just blankets of ice. They were forces of nature, advancing and retreating over thousands of years, carving and crushing everything in their path. For the humans who lived during this time, these ice sheets weren't distant phenomena. They were boundaries that dictated where they could live, hunt, and survive. In the northern hemisphere, the Laurentide ice sheet sprawled across most of Canada and dipped into what is now the northern United States. Cities like Chicago and New York would have been uninhabitable, buried under kilometers of ice. This massive sheet reached as far south as the Ohio River Valley and the Great Lakes region, reshaping the land beneath it. Further west, the Cordilleran ice sheet covered the mountainous regions of western North America, connecting with the Laurentide ice sheet at times to form an almost continuous icy barrier. For the people who roamed these lands, the glaciers dictated movement and survival, forcing them to seek refuge in ice-free areas like Beringia, a land bridge between Siberia and Alaska that allowed humans to migrate into the Americas. Across the Atlantic, the Scandinavian ice sheet dominated northern Europe, enveloping modern-day Scandinavia, parts of the British Isles, and much of Germany and Poland. This massive ice sheet spread southward, creating barriers and altering the courses of rivers. The human populations in Europe found themselves pushed into warmer, ice-free regions like southern France, Spain, and Italy. These areas became refuges where people clustered, developing tools and strategies to survive in proximity to the ice's edge. Glacial meltwaters from these sheets fed rivers that were vital lifelines, carving valleys and creating fertile lands that would support future civilizations. The southern hemisphere wasn't spared the icy grip of the Ice Age either. In South America, glaciers descended from the Andes, covering large swaths of Patagonia and leaving behind dramatic landscapes of fjords, lakes, and valleys. Antarctica, of course, remained a frozen continent, its ice sheets expanding even further outward. In New Zealand, glaciers draped the southern Alps, shaping the rugged terrain into what we now recognize as a haven for dramatic natural beauty. Even parts of Africa felt the icy influence, with glaciers forming on Mount Kilimanjaro in the highlands of Ethiopia. The ice sheets reached their zenith around 20,000 years ago, covering roughly 30% of Earth's land area. At their peak, they trapped so much water that sea levels dropped by over 120 meters, exposing vast tracts of land that connected continents. These land bridges, like the one between Asia and North America, became crucial migration routes for early humans and animals. As the ice sheets began to retreat, the world transformed once again, with meltwater reshaping coastlines and ecosystems. For the people of the time, the ice sheets were both a threat and a backdrop to their existence, immense and unyielding forces that defined the edges of their world. To them, the ice wasn't just a geological feature. It was a force that shaped their lives, their movements, and their survival, carving a world they would eventually reclaim as the ice withdrew. As the glaciers of the Ice Age began to melt, the world witnessed a transformation as profound as the glacial advance itself. Picture oceans creeping inland, inch by inch, reclaiming land that had been dry for tens of thousands of years. This wasn't just a geological event. It was a story of how rising waters reshaped the lives of those who lived on the edges of this changing world. For early humans, who relied on coastlines and riverbanks for food and trade. The melting of glaciers wasn't an abstract process. It was a force that redefined their reality. During the Ice Age, so much water was locked in massive ice sheets that global sea levels were over 120 meters lower than they are today. Vast stretches of land that are now submerged were exposed, creating land bridges that connected continents. Early humans used these routes to migrate, spreading to new territories. But as the glaciers melted, this water returned to the oceans, and those pathways vanished beneath the waves. The land bridge between Asia and North America, known as Beringia, became a memory, cutting off a once accessible migration route. Coastlines redrew themselves, swallowing settlements and hunting grounds that had sustained people for generations. The rising seas were not uniform. Local effects varied depending on how the Earth rebounded from the weight of the glaciers, a process called isostatic adjustment. In areas where the ice had been thickest, the land slowly rose as the glaciers melted, sometimes countering the effects of rising sea levels. But in other places, particularly far from the ice sheets, the water overwhelmed low-lying coasts, submerging fertile plains and changing the course of rivers. These shifts forced humans to move inland, abandoning familiar territories and adapting to new environments. The melting glaciers didn't just flood coastlines. They created new waterways and reshaped existing ones. Rivers swelled with glacial meltwater, carving deeper valleys and altering their paths. Floodplains expanded, providing fertile ground for early agriculture, while deltas grew larger, creating rich ecosystems that supported burgeoning human populations. But with these opportunities came challenges. Sudden surges of meltwater, released when ice dams broke, caused catastrophic floods that swept through valleys and basins, destroying everything in their path. Stories of these ancient floods likely found their way into the oral traditions of early civilizations, shaping myths and legends of great deluges. For those living at the time, the changes must have felt both gradual and overwhelming. Over generations, they would have watched as familiar landscapes disappeared, forcing them to adapt not only their homes, but also their ways of life. Fishing became more important as the expanding seas brought new marine life closer to shore, while the loss of hunting grounds pushed communities to develop new strategies. The melting glaciers were a double-edged sword. On one hand, creating fertile lands and opportunities for settlement, but on the other, taking away territories that had once been secure and stable. The rising seas, driven by the retreating glaciers, were a reminder of the Earth's constant change. For those early humans who faced these challenges, every inch of encroaching water told a story of adaptation, resilience, and the profound power of nature to shape the world they called home. The Ice Age was a time of survival and adaptation, and the animals that lived during this period were as much shaped by the cold as the glaciers themselves. In a world dominated by icy winds and vast expanses of tundra, creatures both massive and small found ways to thrive in conditions that seem unimaginable today. It wasn't just about fur and fat. It was about ingenuity in the face of relentless cold. These animals weren't just passive inhabitants. They were active players in a frozen ecosystem, each carving out a niche in this harsh, breathtakingly raw environment. Woolly mammoths roamed the icy plains, their shaggy coats and curved tusks iconic symbols of this era. These gentle giants grazed on grasses and shrubs, their sheer size a defense against predators. But life wasn't easy for them. Alongside the mammoths were the mastodons, distant relatives that preferred woodlands over open tundra, feeding on leaves and twigs with their less curved tusks. Towering over the plains were the colossal woolly rhinoceroses, their thick fur and large horns helping them battle both the cold and rivals. These solitary beasts were well suited to scraping through snow to reach the tough grasses beneath, a skill that ensured their survival for thousands of years. Meanwhile, saber-toothed cats like Smilodon stalked the megafauna of the time, their elongated canines perfect for delivering deadly bites to prey. These predators weren't just hunters. They were survivalists, competing fiercely for food in an environment where every meal was hard-won. The Ice Age wasn't just the domain of giants. Smaller creatures played just as crucial a role in the ecosystem. Woolly hares and Arctic foxes darted through the snow, their thick fur blending into the landscape to evade predators. Rodents like voles and lemmings thrived beneath the snow, their burrows providing both insulation and protection. These smaller creatures became vital prey for raptors and wolves, ensuring the cycle of life continued even in the coldest regions. Among the predators, the dire wolves were legendary, larger and more robust than modern wolves, hunting in packs that took down prey far larger than themselves. Cave lions prowled the frozen forests, their massive size making them apex predators of their time. And then there were the short-faced bears, towering creatures with powerful limbs and an imposing presence, scavenging and hunting across the icy landscapes. In the Americas, giant ground sloths lumbered through the forests and plains, their enormous claws used not for hunting, but for pulling down branches or digging. Glyptodons, enormous armored creatures resembling giant armadillos, roamed the grasslands, their tough shells offering protection from predators. In Australia, marsupial megafauna like Diprotodon, a massive wombat-like creature, grazed on vegetation, adapting to the cooler, drier climate that the Ice Age brought to their land. The Ice Age seas teemed with life, too. In colder waters, seals and walruses hauled themselves onto icy shores, their thick blubber protecting them from the frigid temperatures. Penguins thrived in the southern hemisphere, while orcas and other predators hunted beneath the ice, demonstrating that even the oceans were a theater of survival and adaptation. Humans shared this world with these creatures, observing, hunting, and sometimes even revering them. Their art, carved into bones and painted onto cave walls, immortalized the animals of the Ice Age. These depictions weren't just records. They were connections, reflections of a time when humans and animals shared a fragile but profound bond in a world dominated by ice. Each creature, whether predator or prey, was part of a vast web of survival, where adaptation wasn't just a strategy. It was life itself. The woolly mammoth and the saber-toothed tiger were masters of survival, embodying the resilience and ingenuity demanded by the unforgiving Ice Age. Each carried a set of adaptations as intricate and purposeful as the icy landscapes they roamed. Their survival wasn't just about enduring the cold. It was about thriving in a world where life clung to the edges of possibility, shaped by frost and scarcity. For the woolly mammoth, survival was written into its body. Its thick, shaggy coat, with layers of coarse outer hair and dense underfur, created an almost impenetrable barrier against the biting cold. Beneath this insulating armor, a layer of fat, sometimes as thick as 10 centimeters, provided both warmth and energy reserves for lean times. Its enormous curved tusks weren't just for show. They were versatile tools for breaking through snow and ice to reach the tough grasses and sedges beneath. Their hump-like shoulders stored fat, a survival mechanism similar to that of modern camels. Even their smaller ears and tails were perfectly adapted to the cold, minimizing heat loss in a way that spoke to eons of evolutionary fine-tuning. Traveling in herds, they found strength in numbers, their social bonds a shield against predators and the harshness of the environment. The saber-toothed tiger, or Smilodon, faced an entirely different set of challenges as a predator. Its iconic elongated canines, capable of delivering precise, powerful bites, were its signature weapon, perfectly suited for taking down large Ice Age prey. Its muscular build gave it immense strength, allowing it to ambush and overpower animals far larger than itself. But brute force wasn't its only asset. Its thick, dense fur provided insulation against the cold, while its stocky limbs made it an efficient stalker in snowy landscapes. Smilodon's keen senses, especially its ability to detect movement and scent over long distances, gave it an edge in a world where missing a meal could mean death. Hunting in groups, much like modern lions, allowed it to take down even the most formidable prey, turning the Ice Age's challenges into opportunities. Both species relied on more than just their physical traits. They adapted their behaviors to the rhythm of the Ice Age. Woolly mammoths migrated across vast territories, following the seasonal growth of vegetation. Their ability to endure long winters and exploit the tundra's sparse resources was as much about instinct as anatomy. Saber-toothed tigers, in turn, adapted to the unpredictable availability of prey. They were opportunistic, able to go without food for extended periods after a successful hunt, storing energy like the predators of today who endure long waits between kills. Yet, survival in the Ice Age wasn't just about battling the elements. It was about navigating a fragile balance within an ecosystem in constant flux. Both species depended on the broader web of life. The plants that sustained the mammoths, the prey that sustained the tigers, and the shared environment that demanded cooperation and competition in equal measure. Their survival was a testament to the resilience of life in the face of almost impossible odds, a reminder of how nature evolves not only to endure but to flourish, even on the edge of the frozen world. The end of the Ice Age was a time of upheaval, a world in flux as glaciers receded and ecosystems transformed. For the megafauna that had ruled this frozen realm, it was as if the very ground beneath their feet was shifting, not just physically, as ice gave way to grasslands and forests, but in the balance of survival itself. These animals, so perfectly adapted to the icy extremes, found themselves caught in a changing world where the skills and traits that had once ensured their dominance now left them vulnerable. The climate was the first and most obvious challenge. As temperatures rose, the vast expanses of tundra and steppe that had sustained mammoths, giant ground sloths, and woolly rhinoceroses began to disappear. These open, grassy plains were replaced by forests or wetlands, ecosystems better suited to smaller, more adaptable animals. The megafauna, reliant on specific diets and expansive territories, struggled to adapt. A mammoth, accustomed to roaming hundreds of miles in search of grass and shrubs, suddenly found its range shrinking as new plant species took over the landscape. Food scarcity became a creeping reality, and for creatures that required massive amounts of sustenance, it was a slow but devastating death sentence. At the same time, another predator was reshaping the world: the rising influence of humans. As Ice Age hunters moved into new territories, they brought with them skills that megafauna had never encountered: coordinated hunting strategies, sharp tools, and a relentless ability to adapt. Early humans saw these massive creatures not as unstoppable giants, but as a source of survival. A single mammoth could provide meat, hides, and bones for tools, enough to sustain a community through harsh winters. For animals like the saber-toothed tiger, humans became competitors, depleting their prey and forcing them to adapt to new hunting strategies or starve. The combination of direct hunting and ecosystem changes driven by human activity, like the use of fire to shape landscapes, created pressures the megafauna had never faced before. It wasn't just a single factor, but a cascade of changes that brought about their downfall. Some populations may have lingered in isolated pockets, finding refuge where the climate and resources still aligned with their needs. But these fragmented groups were vulnerable to the slightest disruption. A harsh winter, a drought, or an encounter with human hunters could wipe out entire herds. For creatures that had once dominated the Ice Age, the world had simply shifted too quickly. The very adaptations that had made them so successful in a cold, harsh environment became their greatest weaknesses in a warmer, more unpredictable one. For the humans of the time, the disappearance of these giants was likely both a loss and a necessity. As the mammoths and rhinos vanished, they would have turned to smaller, faster-breeding animals and new sources of sustenance, marking the transition to farming and more sedentary lifestyles. The extinction of the megafauna wasn't just the end of an era for the animals themselves. It was the beginning of a new chapter for humanity, one shaped by the lessons learned from living alongside these giants in a rapidly changing world. It was a harsh reminder of how fragile life can be when caught in the intersection of climate, competition, and time. Smaller animals and birds faced the Ice Age with a different kind of resilience, one rooted in adaptability and agility. While the megafauna relied on size and strength to weather the cold, these smaller creatures leaned on resourcefulness and rapid changes in behavior. They were the survivors who scurried, flew, and burrowed through a frozen world, finding ways to make the impossible livable. For many small mammals, survival meant embracing the snow and ice rather than resisting it. Rodents like voles and lemmings thrived beneath the snowpack, creating intricate networks of tunnels that offered insulation from the bitter cold above. In these subnivean environments, where the ground stayed just warm enough to keep them alive, they foraged for roots, seeds, and whatever vegetation they could find. This hidden world beneath the snow wasn't just a refuge. It was a miniature ecosystem where life continued despite the harshness above. Rabbits and hares, like the Arctic hare, developed thicker fur and seasonal camouflage, their coats turning white in winter to blend seamlessly into the snowy landscape, hiding them from predators like foxes and owls. Predators, too, had to adapt. The Arctic fox, with its compact body and dense fur, was a master of the tundra, capable of surviving on scraps left behind by larger predators or hunting rodents under the snow. Its keen sense of smell allowed it to locate prey even beneath several feet of ice, and its ability to store fat helped it endure long stretches without food. Similarly, Weasels and ermines took on winter-white coats, their slender bodies perfect for chasing rodents into their burrows, turning the snow into an advantage rather than an obstacle. Birds faced the Ice Age with an incredible array of strategies. Some, like the ptarmigan, stayed put, their feathered feet acting like snowshoes to help them navigate deep drifts. They relied on camouflage and the ability to find food in the most barren landscapes, feeding on buds, twigs, and even moss. Other birds took to the skies, migrating vast distances to escape the cold, following the seasons to ensure a constant supply of food. Geese, ducks, and cranes moved in great flocks, guided by instincts honed over generations, their migrations a testament to nature's ability to adapt on a grand scale. Insects and amphibians, though seemingly fragile, found their own ways to endure. Many entered a state of dormancy, burrowing deep into the ground or beneath logs to avoid the freezing temperatures. Some, like certain frogs, developed antifreeze-like compounds in their bodies, allowing them to survive being frozen solid and then thaw out come spring. Even in the coldest conditions, life found a way to persist, adapting in ways that seemed almost miraculous. For these smaller creatures, the Ice Age wasn't about dominating the landscape, but about navigating its challenges with flexibility and cleverness. They became the threads in a web of survival, supporting predators and scavengers while ensuring the continuation of life through the harshest conditions. Their ability to adapt so quickly and effectively to the ever-changing world of the Ice Age serves as a reminder that survival isn't always about size or strength. It's about the willingness to change, to hide when needed, to move when necessary, and to make a home even in the most unlikely places. The Ice Age feels like a distant, frozen whisper of a world we can barely imagine. It's a time we often romanticize, picturing mammoths trudging through snowy expanses, saber-toothed predators prowling under bleak skies, and humans eking out survival in caves. But the creatures that define that era haven't all vanished like ghosts into history. Some, remarkably, have left behind descendants that still roam among us today, though they may be unrecognizable from their Ice Age ancestors. It's fascinating, really, how evolution molds survival into subtle shapes. Take the mighty woolly mammoth, for instance, one of the quintessential icons of the Ice Age. While they're long gone, their close relatives, the Asian elephants, carry their genetic legacy. When you look into the soulful eyes of an elephant, you're peering into a history that stretches back to a time when the world was locked in ice. In fact, the DNA overlap is so strong that scientists have even toyed with the idea of de-extincting mammoths by using their genetic material. It's a thought as thrilling as it is unnerving, raising questions about whether we should revive the past or let it rest. The giant ground sloths, those enormous, lumbering creatures that once dominated the Americas, seem like they belong to a world utterly removed from ours. But today's tree sloths, those slow, contemplative dwellers of forests, are their much smaller, more modest descendants. When you watch a sloth inch its way along a branch, it's almost like catching a glimpse of the distant echoes of those prehistoric giants. The connection is subtle, but it's there, hidden in the way they move and survive. Then there are the great predators of the Ice Age, like the fearsome saber-toothed cats. While their saber-toothed lineage didn't make it through the ages, the big cats we see today, lions, tigers, leopards, are part of the same predatory legacy. They've adapted to a warmer, greener world, trading ice and snow for savannas and jungles, yet their eyes and instincts carry the essence of an era when survival meant something altogether harsher. Even some of the less dramatic creatures from the Ice Age have living ties. Musk oxen, with their shaggy coats and resilience to the cold, still wander the Arctic, like remnants of a time when the cold ruled the earth. Their endurance is humbling, a testament to how life clings on through unimaginable adversity. Reindeer, too, so entwined with modern mythology, are direct descendants of Ice Age species that thrived in the tundra. Their migrations today echo patterns set long before humans ever dreamed of guiding them with sleighs. What's most compelling, perhaps, is how some Ice Age survivors live on not just in genetic remnants, but in cultural memory. Human stories and art have preserved their images. Mammoths etched into cave walls, saber-toothed cats immortalized in myth. It's as if our ancestors wanted to ensure that these creatures, so integral to their existence, wouldn't just fade into obscurity. And in a way, they've succeeded, because even now, we feel connected to a world we've never known. What strikes me most is how fragile and resilient life is all at once. The Ice Age was a time of extremes, freezing temperatures, relentless challenges. And yet, here we are, sharing the planet with distant echoes of that frozen world. It's a strange, almost poetic reminder that while the world changes, some threads of life manage to weave their way through history, connecting us to a past we can barely fathom. It makes you wonder how much of today's world will leave its mark on the distant future, and what creatures might look back on us as part of their ancient lineage. During the Ice Age, survival was a delicate balance of ingenuity, adaptability, and sheer determination. Early humans found themselves in an unforgiving world where vast glaciers crept across the land and frigid winds cut through the barest of shelters. It was not just about enduring the cold. It was about navigating a landscape where resources were sparse and the odds of survival were stacked high against them. Their days began and ended with the primal need to stay alive, but within that struggle lay a spark of resilience that would shape the course of human evolution. Shelter was often the first line of defense against the relentless cold. Early humans sought refuge in caves, their dark recesses offering a shield from icy gusts and the piercing chill of winter nights. When caves were not available, they constructed shelters from animal hides stretched over wooden frames or dug into the earth to create insulated pits. Every stone and piece of bone they worked into tools became a means of survival. Scrapers to tan hides for clothing, blades to butcher meat, and needles to stitch together fur garments that provided crucial protection from the elements. Fire was more than warmth. It was life itself. A roaring fire in the midst of an Ice Age night transformed the world around it into a haven. It was a beacon of hope, a source of light, a way to cook food that was otherwise difficult to digest, and a barrier against the predators prowling the frozen wilderness. Learning to kindle and sustain fire was not just a skill. It was a shared responsibility that bound groups together, each person contributing to the small, flickering heart of their survival. Food was always a challenge. Early humans hunted large Ice Age animals like mammoths, bison, and reindeer, using teamwork and carefully crafted tools to bring down creatures much larger and stronger than themselves. The hunt was dangerous, often requiring days of tracking and the courage to face beasts that could easily turn the tables. Every part of the kill was utilized: meat for sustenance, bones for tools, and hides for warmth. When hunting failed, they turned to gathering roots, berries, and edible plants buried beneath the snow, relying on generations of passed-down knowledge to distinguish between nourishment and poison. Community was essential. Small bands of humans moved together across the frozen terrain, sharing resources, dividing labor, and relying on one another in moments of crisis. The bonds forged in this time were more than practical. They were emotional lifelines that carried individuals through the harshest conditions. Around the fire, they shared stories, passed down lessons, and perhaps even comforted one another against the howling winds outside. It was this sense of shared purpose, of finding strength in numbers, that allowed early humans to endure challenges that no one person could face alone. Adapting to the cold also meant an evolving understanding of the world. They read the landscape like a map, recognizing signs of migrating herds, the first shoots of spring plants, or the safest paths across treacherous ice. Over time, their bodies began to reflect the demands of the environment, with physiological traits that improved their ability to conserve heat, endure long treks, and survive on high-protein diets. Through it all, the Ice Age was a crucible that tested the limits of human endurance. It demanded not only survival but also creativity and cooperation, forcing humans to develop skills and relationships that would define them as a species. Every step they took on the icy ground was a testament to their ability to face overwhelming odds with ingenuity and hope, a legacy that still echoes in the human spirit today. In the shadow of the Ice Age, tools and technologies became lifelines, born not just from necessity but from a deep and instinctual drive to shape the world around them. These early innovations were not grand or polished, but they carried with them the weight of survival. Every sharpened edge, every fitted joint, every spark of fire represented countless trials and errors, shared knowledge, and moments of revelation. Tools were not just objects. They were extensions of the human will, carrying the ingenuity of their makers through the bitter cold. Stone tools, though deceptively simple by today's standards, were masterpieces of utility and adaptation. Flint knapping, the process of shaping stones into sharp edges, became an art form. Early humans struck stones with precise force, chipping away flakes to create scrapers, knives, and projectile points. These tools weren't just for hunting, they were multi-purpose solutions. Scrapers turned rough hides into pliable leather for clothing and shelter, while knives transformed carcasses into sustenance. A skilled napper was a cornerstone of any group, their expertise as critical as the hunters who brought down the prey. The spear was another marvel, a testament to the balance of precision and strength. At its core was the understanding of leverage and aerodynamics. Early humans learned to attach sharpened stone or bone points to wooden shafts using animal sinew and plant fibers, creating weapons capable of piercing the thick hides of mammoths and bison. Over time, they added complexity, developing atlatls, spear-throwing devices that allowed them to hurl projectiles farther and with greater force. Each improvement carried the whispered stories of previous failures, the quiet determination to do better. Clothing was an innovation as vital as any weapon. In the unforgiving cold, the body's own defenses were woefully inadequate. Early humans turned to the hides and furs of the animals they hunted, fashioning garments that insulated them against the bitter winds. But these weren't crude wraps. They were thoughtfully constructed pieces, stitched together with bone needles and sinew threads. Layering techniques were discovered, and garments were designed to trap heat while allowing mobility, ensuring that the wearer could hunt, gather, and move with purpose. Firemaking was a cornerstone of Ice Age technology, yet its mastery required a level of patience and understanding that bordered on reverence. Flint and pyrite stones became the tools of transformation, striking against one another to create the sparks that could ignite dry tinder. It wasn't enough to make fire. They had to nurture it, feeding it the right materials and shielding it from the relentless winds. The ability to make and sustain fire became one of the most sacred and closely guarded skills within a group, passed from one generation to the next. Even the most basic seeming innovations carried profound weight. The creation of storage technologies, such as digging pits to preserve meat or weaving baskets to gather food, reflected a growing awareness of time and the need to prepare for leaner days. Bone and antler tools, shaped into awls, needles, and even decorative items, showed that utility could coexist with a sense of beauty and identity, hinting at a developing sense of self and community. As the Ice Age wore on, these tools and technologies were not static but evolving, adapting to the shifting needs of survival. Every chipped stone and stitched seam bore the fingerprints of the people who made them, the echoes of their struggles, and the triumphs of their ingenuity. They were not just objects but the embodiment of a profound human story. A story of a species that refused to be defined by its limitations, crafting a path forward in the face of overwhelming adversity. The story of human life during the Ice Age is written in fragments scattered across time, pieced together like a mosaic of survival and ingenuity. Every artifact, every trace left behind in the frozen earth or rocky caves, speaks to the existence of people who faced unimaginable challenges yet carved out a place for themselves in an unforgiving world. These remnants are more than just objects or fossils. They are echoes of lives lived, moments of ingenuity, and the persistent rhythm of human activity. In caves where they sought shelter, we find not only tools but also signs of their creativity and their attempts to understand the world. Handprints pressed against rock walls, pigments smeared into vivid scenes of animals and hunts, and abstract symbols carved into stone offer glimpses into their thoughts and experiences. These works of art are not mere decoration. They are a connection to the hopes, fears, and stories of Ice Age humans, a record of their presence that transcends the millennia. Scattered across ancient landscapes are tools and weapons that tell a tale of adaptation. Sharpened flint blades, bone needles, and spear points, some worn smooth by use, reveal a people who honed their skills with each generation. The remains of hearths, often surrounded by charred bones and ash, point to places where fire brought warmth, light, and community. In these hearths, researchers uncover fragments of burned food, bits of bone, plant matter, and even fat, giving a detailed view of what sustained them during times of scarcity. Burial sites offer some of the most poignant evidence of Ice Age life. Bodies carefully laid to rest, sometimes adorned with beads, tools, or ochre, show an awareness of death and perhaps a belief in something beyond it. These graves speak of connection and care, of rituals that may have bound communities together even as they faced the uncertainties of survival. Teeth and bones preserved in these burials tell us about their diets, health, and even the injuries they endured. Marks of a life both brutal and resilient. The skeletal remains of animals, often found alongside tools, highlight the deep interconnection between humans and their environment. Mammoths, bison, reindeer, and smaller game animals bear the scars of hunts. Cut marks on bones where meat was stripped away, evidence of efficient butchering techniques. In some cases, entire campsites have been uncovered, with bone fragments arranged in ways that suggest not just survival but an organized effort to thrive, to make the most of what the Ice Age landscape offered. Even the very land bears witness to their presence. Footprints, preserved in ancient mud and now fossilized, show the paths they walked, sometimes alone, sometimes in groups. These footprints are hauntingly human, with a familiarity that bridges the vast gulf of time. They remind us that these were people like us, walking, working, and finding moments of connection in a harsh and shifting world. Through these fragments, we are piecing together a narrative of determination and adaptability. Each discovery, no matter how small, is a thread in a tapestry that shows how Ice Age humans lived not as isolated individuals, but as communities that shared their burdens and their triumphs. The evidence they left behind is not just proof of their existence, but a testament to the enduring spirit of humanity, a reminder that even in the coldest of times, life found a way. The Ice Age shaped the course of human migration in profound ways, driving people to move not out of mere curiosity, but out of necessity, survival, and opportunity. As glaciers advanced and retreated, they carved the Earth into new landscapes, creating pathways and barriers that would dictate where and how humans traveled. The harshness of the Ice Age forced them to constantly adapt, to read the land like a story written in ice and stone, and to follow the rhythms of a world that was always changing. During colder periods, sea levels dropped dramatically, exposing vast stretches of land that are now submerged beneath oceans. These land bridges, such as the one between Siberia and Alaska, opened up new frontiers for exploration. For the groups of humans who crossed these icy thresholds, it was a journey into the unknown, driven by the promise of food, shelter, and a better chance at survival. They weren't just wandering. They were chasing herds of animals, seeking fertile ground, and escaping regions where the cold had made life unbearable. Every step forward was a gamble, each new horizon a question mark. The shifting climate also created corridors of opportunity, places where humans could find refuge from the worst of the cold. River valleys, coastlines, and areas near receding glaciers became lifelines, providing water, game, and edible plants. These routes often became highways of human movement, with groups following the same paths year after year, leaving behind faint traces of their passage. Tools, hearths, and sometimes the remains of their dead. These corridors weren't just about survival. They became conduits for the exchange of ideas, tools, and traditions, spreading knowledge across vast distances. For those moving into colder regions, the migration wasn't just physical but deeply transformative. They had to learn how to hunt animals that were larger and more dangerous, to build shelters capable of withstanding freezing winds, and to find ways to store food during long, barren winters. Their bodies and cultures adapted to these challenges, shaping everything from the tools they made to the stories they told around the fire. For others, the changing climate pushed them into warmer, more hospitable regions, where they encountered new environments that required entirely different strategies for survival. But migration wasn't always a choice. Sometimes it was forced by the sheer uninhabitability of the land. Entire groups were displaced as glaciers expanded, swallowing the places they had called home. In other moments, the retreat of the ice opened up vast new territories, inviting humans to spread out into regions that had been inaccessible for millennia. This ebb and flow of ice and warmth created a cycle of movement that defined the human experience during the Ice Age, a constant push and pull between staying and going, between holding on and letting go. Every migration left its mark on the people who undertook it. The Ice Age didn't just scatter humans across the globe, it shaped who they became. It forged resilience, taught them to adapt to the harshest conditions, and built a species capable of surviving and thriving in nearly every environment on Earth. The footprints left in the snow and the artifacts buried beneath layers of ice and soil are not just evidence of movement. They are the echoes of countless decisions, sacrifices, and triumphs that allowed humans to carve out a place for themselves in a world of endless challenges. The Ice Age was a relentless teacher, forcing humans to confront the extremes of nature with little more than their hands, their minds, and an unyielding will to survive. In this crucible of cold and scarcity, the challenges they faced didn't just demand resilience. They demanded creativity. Innovation wasn't a luxury. It was the difference between life and death, and every small advance carried the weight of survival. The biting cold, the unforgiving landscapes, and the constant threat of hunger pushed humans to think in ways they never had before. And it was through this pressure that ingenuity flourished. Fire, once a precarious discovery, became an indispensable tool, and its mastery was refined during these harsh times. Early humans learned not only to create it more efficiently, but to harness it in new ways, drying meat for preservation, hardening wooden tools, and even reshaping their environments. They experimented with different materials for kindling and perfected techniques to ignite sparks even in damp or frozen conditions. Fire became a companion, a symbol of human tenacity, and a tool for transforming the elements themselves. Hunting strategies evolved rapidly, driven by the need to bring down enormous Ice Age creatures that provided both sustenance and raw materials. This wasn't just brute force. It required planning, cooperation, and the development of specialized tools. Spear points became sharper, atlatls allowed greater range, and traps became more sophisticated. Over time, humans learned to work together in complex hunting groups, using their combined skills to outwit prey that was faster, stronger, or better adapted to the cold. These innovations weren't static. They were refined and passed down, each generation improving on what the last had built. The environment itself became a canvas for invention. Shelters evolved from simple hide tents to complex structures that incorporated bones, tusks, and even large stones for insulation. Clothing, too, became a realm of experimentation. The harsh winds and freezing temperatures drove early humans to create layered garments, weaving together animal hides and furs in ways that maximized warmth while allowing freedom of movement. Bone needles and sinew threads were delicate but essential tools in this endeavor, each stitch a testament to ingenuity under pressure. Even food gathering took on a new level of sophistication. With the cold often limiting access to plants, humans found ways to store and ration meat, to identify and exploit seasonal resources, and to process what they found for maximum nutrition. They experimented with grinding stones to crush seeds and roots, developing rudimentary forms of cooking that unlocked nutrients otherwise unavailable. These were not just acts of survival. They were acts of imagination, of seeing possibilities in the harshest of conditions. Art and symbolic thought, too, blossomed during this time, as humans began to create tools not just for function but for meaning. The carvings and cave paintings that emerged during the Ice Age suggest that, even amidst hardship, people sought to understand their place in the world and to communicate ideas that went beyond the immediate needs of survival. These creations hint at a growing complexity of thought, a spark of the creativity that would later define humanity. The Ice Age didn't just challenge humans. It forced them to look inward, to draw on their capacity for problem solving, and to collaborate in ways that no other species had before. Every tool, every strategy, every shared lesson was a step forward, born of necessity but carrying with it the seeds of progress. These innovations weren't just reactions to hardship. They were the beginnings of a pattern, a deep and enduring drive to shape the world rather than be shaped by it. The Ice Age may have tested humanity to its limits, but in doing so, it ignited a flame of creativity that would burn brighter with each passing generation. The Ice Age was a world transformed, its climate so starkly different from today that it would feel almost alien to us. Massive glaciers stretched across vast portions of the Earth, reshaping the land beneath them with their slow, relentless movement. What is now fertile farmland or bustling cityscape was once buried under miles of ice, silent and crushing. The air itself was colder, drier, and often harsher, carrying winds that swept across open tundras and barren plains. Life clung to the edges, adapting to the extremes or retreating to the rare pockets of warmth and abundance. Seasons were sharper, their boundaries etched by the movements of the glaciers. Winters were longer and more brutal, freezing rivers and lakes into solid sheets, while summers, though warmer, were often brief and fleeting. In many regions, temperatures rarely reached the mild warmth we take for granted today. Entire ecosystems adapted to this rhythm, creating a landscape dominated by hardy vegetation and resilient animals. Grasslands and steppes stretched across continents, populated by mammoths, woolly rhinos, and reindeer. Creatures built to endure the cold in ways humans could only marvel at. Regions closer to the equator, though spared the ice, felt the ripple effects of the Ice Age. Rainfall patterns shifted dramatically, with some areas becoming drier and others wetter as the global climate adjusted to the icy grip of the poles. Forests receded in many parts of the world, replaced by open plains or scrubland, and deserts expanded in others. The world's oceans also transformed, their levels dropping as water became locked in the glaciers, exposing new coastlines and land bridges. These changes created opportunities for migration, but also new challenges as familiar environments disappeared. The sheer scale of the ice sheets was impossible to ignore. They reflected sunlight back into space, creating a feedback loop that kept the planet locked and cold. Yet even within this seemingly frozen world, there was movement. Glaciers advanced and retreated in cycles, carving valleys, shifting rivers, and depositing massive amounts of rock and sediment. The landscapes we know today, fjords, moraines, and even some of the Great Lakes, owe their existence to the slow, grinding power of Ice Age glaciers. For humans, the climate of the Ice Age was a constant challenge. It shaped every decision, every tool, and every movement. They had to learn the rhythms of the land, to find the rare places where life could flourish, and to adapt their lives to a world that demanded ingenuity at every turn. The stark contrast between Ice Age climates and today's warmer, more stable conditions remind us of the delicate balance that allows life to thrive. The Ice Age was a time of extremes, but it was also a time of incredible transformation, laying the foundations for the world we now call home. The Ice Age was a world of unrelenting cold, where the average global temperature hovered roughly 6 to 8 degrees Celsius lower than today's. While that difference might sound modest, it was enough to drape vast parts of the planet in ice, reshape continents, and create an environment where survival was a constant struggle. In the heart of the glacial periods, temperatures in some regions dipped to bone-chilling extremes, plunging far below freezing for much of the year. Even in the warmer interglacial phases, the world was far colder and harsher than the one we know now. This wasn't a uniform chill blanketing the globe. The equatorial regions, while spared the glaciers, were cooler and drier, with forests giving way to savannas and deserts creeping into areas once rich with life. Meanwhile, in the higher latitudes, entire landscapes disappeared beneath miles of ice, their inhabitants forced to migrate or adapt to the bitter cold. The polar regions, as you might imagine, were the harshest of all, with temperatures plunging so low that they defy comprehension, creating a world of perpetual frost. For humans, this cold was not just a backdrop but a daily reality that shaped their existence. Each icy gust, every frost-covered morning, was a reminder of the delicate balance they lived within. Fire became their most cherished companion, not just for warmth, but for the hope it brought against the encroaching cold. Clothing made from the furs of hunted animals was a necessity, stitched together with meticulous care to seal in whatever heat their bodies could generate. The cold wasn't just an environmental condition. It was a force that demanded respect and ingenuity, a constant presence that shaped their tools, shelters, and even their migrations. Yet, even amidst this chill, there were moments of respite. Summers, though brief, brought a reprieve from the cold, a chance for plants to bloom and animals to graze. These fleeting warmer months became lifelines, times to gather resources, prepare for winter, and find the strength to endure. The Ice Age temperatures were not merely numbers on a scale. They were the rhythm of a world in flux, a constant reminder of nature's power and humanity's determination to persevere within it. The Ice Age redefined the natural world, forcing plants and ecosystems to adapt, shift, or vanish entirely under the weight of ice and the relentless cold. It was a time when vast glaciers sprawled across continents, scraping the land clean and burying entire ecosystems beneath miles of ice. Where forests and meadows once thrived, there was now only a stark expanse of frozen silence. Plants, rooted in their habitats and unable to flee, faced the full brunt of these changes, and their survival depended on resilience and the ability to exploit the rare pockets of life-sustaining conditions that remained. In the frozen regions, where glaciers dominated, plant life was almost entirely absent. Only lichens and a few hardy mosses clung to life on exposed rocks, surviving in the cracks and crevices that offered slight protection from the wind and frost. Just beyond the glaciers, tundra landscapes stretched for miles, a fragile yet tenacious ecosystem of low grasses, shrubs, and sedges. These plants were masters of endurance, growing slowly in the short summer months and enduring long, brutal winters by lying dormant beneath snow and ice. Farther south, where the cold eased but the climate remained unforgiving, vast steppe ecosystems took hold. These grasslands were unlike anything we see today, dominated by tough, drought-resistant grasses and scattered patches of shrubs. They were built for extremes, providing enough sustenance to support herds of mammoths, bison, and woolly rhinoceroses. But even these ecosystems were delicate, finely tuned to the harsh conditions. A slight shift in temperature or moisture could alter the balance, forcing plants and the animals that depended on them to adapt or disappear. Forests, meanwhile, retreated in the face of advancing ice and shifting climates. Boreal forests of hardy conifers like spruce and pine hung on at the edges of the ice, their needles and thick bark adaptations to the cold. Deciduous forests, once widespread, shrank into isolated pockets, clinging to life in sheltered valleys or along riverbanks where the cold was less severe. The diversity of plant life diminished in many regions, with only the hardiest species able to survive the swings between freezing winters and brief, intense summers. For humans, these changes in plant life shaped every aspect of their survival. The tundra and steppe provided essential resources: roots and tubers that could be dug from the frozen soil, berries that ripened in the fleeting warmth, and grasses that fed the game they hunted. Forests, when they could be found, offered not only food but materials for tools, shelter, and fire. Yet, every resource was precious, every harvest a gamble, as plants struggled to produce under the conditions imposed by the Ice Age. The Ice Age ecosystems were marked by a stark beauty, a testament to life's ability to persist in the face of immense challenges. Plants adapted, ecosystems transformed, and the natural world reshaped itself again and again, creating a dynamic interplay between survival and extinction. These were not static landscapes but living systems, responding to every advance and retreat of the glaciers, every shift in temperature or rainfall. And through it all, plants remained the quiet foundation of life, holding ecosystems together in a world defined by ice and change. The Ice Age was a sculptor of the skies, carving the patterns of modern weather through its immense influence on the Earth's atmosphere, oceans, and landscapes. The glaciers that blanketed so much of the world were not just passive giants. They were active agents in shaping how air and water moved across the planet. Their presence created a unique climate dynamic, one that rippled forward through time and left a lasting imprint on the systems that govern our weather today. During the Ice Age, the vast ice sheets acted as enormous mirrors, reflecting sunlight back into space and keeping global temperatures colder than they might otherwise have been. This cooling effect was not limited to the regions directly beneath the ice. It altered atmospheric circulation on a global scale. Air masses shifted, creating powerful winds that carried cold, dry air far beyond the edges of the ice. These winds shaped patterns of precipitation and drought, determining where rain or snow would fall and where lands would become arid and barren. The oceans, too, played a critical role. With so much water locked in ice, sea levels dropped dramatically, exposing new coastlines and altering the flow of ocean currents. These currents, which distribute heat around the globe, were disrupted by the changing topography of the seafloor and the influx of cold, fresh water from melting glaciers. The Atlantic Ocean's circulation, in particular, was profoundly affected, its rhythms slowing and shifting in ways that would influence everything from European winters to tropical monsoons. In regions closer to the equator, the Ice Age created a push and pull effect. While these areas were spared the freezing temperatures, they were not untouched. Shifts in atmospheric circulation patterns brought drought to some areas and increased rainfall to others. The Sahara, for instance, oscillated between arid desert and lush grassland depending on the global climate swings. These changes were deeply tied to the way the Ice Age modulated heat and moisture, creating conditions that still resonate in the regional weather systems of today. As the Ice Age ended and the glaciers retreated, the land itself began to recover, but the effects of their presence lingered. The massive weight of the ice had compressed the Earth's crust, and as it rebounded, it altered the tilt and wobble of the planet, subtly affecting seasonal cycles and solar radiation patterns. Rivers and lakes carved by the glaciers rerouted water systems, influencing local climates and creating fertile valleys that would become centers of human civilization. The shifting coastlines and newly exposed lands also affected wind patterns, altering the distribution of heat and moisture in ways that persist even now. The Ice Age was not just an era of cold. It was a time of profound transformation. It forced the planet into a new equilibrium, one where glaciers, oceans, and the atmosphere were locked in a dynamic dance. Modern weather patterns, our monsoons, trade winds, and even the storm tracks that dominate our daily lives, owe their origins to the legacy of this time. The Ice Age reshaped the Earth's climate systems, embedding its influence in the rhythms of wind, water, and temperature that define our world today. Every gust of wind, every raindrop, carries a trace of the Ice Age's enduring touch, a reminder of how deeply the past shapes the present. The Ice Age was a time of upheaval, not just for the land but for the life that depended on it. As glaciers advanced and retreated, the distribution of species across continents was dramatically reshaped. Animals and plants, bound by their need for specific conditions, were forced to move, adapt, or perish. This constant push and pull created a dynamic and evolving map of life, with species migrating across vast distances or finding refuge in isolated pockets where they could endure the harsh climate. For many species, survival meant following the ice. Large herbivores like mammoths and woolly rhinoceroses thrived on the cold, open steppes that spread across Europe, Asia, and North America. These grasslands, rich in tough, frost-resistant plants, became the stage for a migration cycle tied to the rhythm of the glaciers. Predators, from saber-toothed cats to dire wolves, followed their prey, creating a web of life that stretched across continents. These migrations weren't leisurely wanderings but acts of necessity, driven by the search for food and suitable habitats as ice advanced or receded. In the warmer regions of the planet, where glaciers never reached but the climate still shifted dramatically, the distribution of species also changed. Forests expanded and contracted depending on rainfall and temperature, pushing animals like elephants, antelope, and early primates to adapt to new environments. Some species found themselves stranded in isolated areas as their habitats were cut off by deserts or mountains, leading to the evolution of unique traits and even entirely new species. This isolation helped shape biodiversity in places like the tropical rainforests and highlands, where remnants of Ice Age ecosystems can still be seen today. The drop in sea levels during the Ice Age revealed land bridges that connected continents, opening up new routes for migration. The Bering Land Bridge between Asia and North America allowed species to cross into new territories, creating a mingling of faunas that hadn't interacted before. Humans, too, used these paths, following the herds of animals they depended on. This movement of species across land bridges created opportunities for competition, adaptation, and sometimes extinction as new ecosystems adjusted to the arrival of unfamiliar life. Not all species were so mobile. Some retreated to refugia, small areas that offered protection from the cold, such as valleys, caves, or coastal regions where temperatures were more stable. These refuges became genetic reservoirs, places where life could hold on until the ice retreated. Over generations, species adapted to these conditions, emerging from these pockets when the climate warmed to repopulate the land. This pattern of retreat and expansion left its mark on the genetic diversity of species, creating populations with subtle differences depending on where they had weathered the Ice Age. The Ice Age didn't just scatter life. It reshaped the rules of survival. It forged new ecosystems, blending species from different continents and creating opportunities for evolution. The scars and legacies of these migrations remain etched into the fabric of life on Earth today. The animals and plants we see around us, their distributions and adaptations, carry the echoes of a time when glaciers ruled the Earth and life bent itself to their will. The end of the Ice Age is a story etched into the bones of the Earth and whispered through the ruins of ancient human lives. It was a time of profound transformation, a slow yet relentless thawing that reshaped landscapes and the destinies of those who lived through it. Around 12,000 years ago, the world began to warm, marking the end of the Pleistocene epoch and ushering in the relatively stable climate of the Holocene. This was not an abrupt event, but a gradual unraveling, driven by a complex interplay of forces both cosmic and terrestrial. Shifts in Earth's orbit, known as Milankovitch cycles, subtly altered the distribution of sunlight across the planet. These orbital variations, combined with a growing concentration of greenhouse gases like carbon dioxide and methane, tipped the scales. As ice sheets retreated, their reflective surfaces gave way to darker Earth and ocean, absorbing more heat and accelerating the warming process. It was a feedback loop, a chain reaction where each step nudged the planet further from its icy grip. For early humans, this transition was as much a challenge as it was an opportunity. Nomadic bands who had adapted to the harsh Ice Age conditions now faced a world in flux. Mammoths and other megafauna, creatures they had hunted for generations, began to disappear, victims of a changing climate and perhaps overhunting. River valleys and coasts, once buried under kilometers of ice, opened up, offering new lands to explore and settle. But this shifting world was fraught with unpredictability. Melting glaciers unleashed massive floods, reshaping the terrain in cataclysmic moments. Lakes formed and vanished, rivers carved new paths, and the very ground itself seemed to pulse with change. Imagine a family huddled around a fire in the shadow of a melting glacier, watching as their environment transformed before their eyes. The air, still cold but no longer biting, carried unfamiliar scents of growing vegetation. The distant roar of collapsing ice echoed across the land, a sound both ominous and full of promise. The tools they crafted, the stories they told, and the paths they chose to walk all evolved in response to a world that was simultaneously softening and destabilizing. These were not abstract forces, but deeply personal realities. The end of the Ice Age rewrote the map of the world, flooding what had been dry land and connecting isolated regions. It pushed humans to adapt, to innovate, to find new ways to thrive. It set the stage for the rise of agriculture, permanent settlements, and the civilizations that followed. The human story is inseparable from the rhythms of the planet, and in the end of the Ice Age, we see a pivotal chapter, a time when survival demanded resilience, creativity, and an unyielding connection to the ever-changing Earth. The extinction of megafauna, those giants that once roamed the Earth, is a story of complexity and intertwined fates, both human and natural. It was not a single event but a tapestry of causes and consequences, woven together by the changing climate and the arrival of a new, remarkably adaptable predator, humans. Imagine standing on a windswept plain as a hunter thousands of years ago, gazing at the immense form of a mammoth or a towering ground sloth. These creatures, awe-inspiring and central to survival, were both a gift and a challenge. But their world, and yours, was shifting. As the Ice Age ebbed away, the warming planet reshaped the ecosystems on which these animals relied. Grasslands shrank, replaced by forests and wetlands, altering food supplies. Seasonal rhythms, so deeply ingrained in their survival strategies, became unpredictable. Some megafauna, highly specialized for cold climates or particular diets, found themselves unable to adapt quickly enough to these rapid changes. It wasn't merely a matter of warmer temperatures, but the cascading effects on entire ecosystems. Plants, prey species, migration routes, all shifting like sand beneath their feet. And then there were humans, spreading across continents, bringing ingenuity and determination wherever they went. Armed with sharpened tools and coordinated hunting strategies, they were unlike any predator these animals had faced before. A spear might not bring down a mammoth alone, but a group of hunters, working in unison, could outmaneuver and overpower even the largest beasts. To humans, this was not destruction. It was survival. The fat and meat sustained families through harsh winters, while bones and hides became tools and shelters. But as the hunt continued, populations of these slow-reproducing giants dwindled. It's tempting to place blame squarely on one factor or the other, climate or humans. But the truth lies in their intersection. Some regions saw megafauna vanish before significant human presence, suggesting climate's heavy hand. In others, extinctions followed quickly after human arrival, implying that hunting tipped the balance. In reality, these forces were inseparable. Climate change weakened the giants, narrowing their habitats and reducing their numbers. Into this precarious balance stepped humans, exploiting vulnerabilities with devastating efficiency. For the people of that time, this extinction was not a moral failing but an unintended consequence of survival. They lived in a world where every decision was a negotiation with nature, where taking down a massive animal could mean life for a village, but unknowingly spelled the end for a species. As we sift through their bones and tools today, we are reminded of how delicate that balance can be. The extinction of megafauna is a story of adaptation and impact, of human ingenuity meeting natural fragility. It echoes forward, a lesson in how intertwined we are with the world's rhythms, and how, sometimes, even survival carries a weight we cannot fully measure. The idea of another ice age feels like something out of a distant, mythical future, yet it is rooted in the natural rhythms of our planet's history. For millions of years, Earth has cycled between glacial and interglacial periods, and in some ways, we are overdue for the return of another icy chapter. But the question is no longer just about the Earth's natural tendencies. It's about us. What we've built, what we've changed, and how deeply intertwined we've become with the planet's fate. Imagine a family in a distant future, bundled against cold winds that bite sharper than today's winters. They stand in a landscape altered not only by time, but by the choices made long before they were born. The glaciers that once covered vast swathes of the world might return, creeping slowly, claiming lands that were once bustling with cities and farmlands. But what would drive such a change, and could we even recognize it in its earliest whispers? Earth's orbit and tilt, part of the Milankovitch cycles, are the metronomes of glacial ages, setting the pace for when sunlight warms the planet more or less intensely. These gradual shifts, over tens of thousands of years, dictate whether ice sheets grow or retreat. Without human interference, this natural rhythm suggests that, eventually, glaciers would once again expand, swallowing northern forests and prairies. But the planet we've shaped through industrialization and fossil fuel combustion has thrown a wrench into this delicate clockwork. Carbon dioxide, methane, and other greenhouse gases have blanketed the atmosphere, trapping heat and creating a world where natural cooling may be delayed or even prevented entirely. In a way, we've pressed pause on the next ice age, though not with intention. What might have been a gentle descent into cooler times has been counterbalanced by the heat of human progress. Some scientists argue that, without the influence of human-made emissions, glaciers could have begun their slow march within the next 50,000 years. Now, that timeline is uncertain, stretched, or possibly erased altogether. But there's a paradox in this story. The very systems we rely on to shield us from the cold, a warmer global climate, thriving agriculture, and stable coastlines, are also precariously balanced. If we disrupt Earth's climate too far, tipping it into chaos, unexpected feedback loops could emerge. Changes in ocean currents or polar ice melting might provoke localized cooling events, even as the planet as a whole warms. It's not so much a question of whether another ice age could come, but whether we'd even recognize its approach amidst the turmoil we've created. The future of an ice age isn't just about the whims of geology or climate science. It's about humanity's place in shaping those forces. Could our descendants face frozen landscapes, struggling as early humans once did to survive against icy odds? Or will we have fundamentally rewritten the script, erasing one of the Earth's most ancient rhythms in favor of an uncertain warmth? The answer lies not in inevitability, but in the choices we make now. Choices that will echo long after the last vestiges of today's glaciers are gone. The Ice Age, with its glaciers sprawling over continents and harsh, unpredictable climates, might seem like an unlikely time for human flourishing, yet it was a period of resilience, creativity, and adaptation. While grand civilizations as we know them today did not exist, scattered groups of humans carved out lives against this challenging backdrop, thriving in ways that reflected their deep ingenuity and intimate connection with the natural world. Their stories, though fragmented, are etched into tools, cave art, and the bones of the animals they hunted, offering glimpses of a world vastly different from our own. Picture a small group of humans gathered in the shelter of a rocky overhang, their fire flickering against the cold darkness of an ice age night. Outside, the winds howl across a frozen tundra, but inside, they share warmth, stories, and the spoils of their latest hunt. These were the people of the Upper Paleolithic, a time when Homo sapiens were spreading across the planet, adapting to environments as diverse as glacial Europe, the open savannas of Africa, and the icy edges of Asia. Their survival depended on a profound understanding of their surroundings, tracking game through snow, finding edible plants in sparse landscapes, and navigating the seasons with precision. In Europe, groups like the Gravettians and later, the Magdalenian culture flourished in the shadow of glaciers. They hunted mammoths, reindeer, and bison, crafting sophisticated tools from stone, bone, and ivory. Their shelters, often made of mammoth bones and hides, were marvels of resourcefulness. But they were not merely surviving, they were creating. In the depths of caves, they painted breathtaking images of animals and symbols, their art speaking to a connection with the world that was both practical and spiritual. These paintings, such as those in Lascaux and Chauvet, endure as testaments to their ingenuity and imagination. Further east, humans migrated into Siberia and across the frozen land bridge into the Americas. These groups faced environments where temperatures plummeted far below freezing, yet they thrived. They developed clothing from animal hides tailored to shield against the cold, weapons for hunting massive creatures like the woolly mammoth, and strategies for living in close-knit communities where cooperation was essential. Their movement into the Americas marked one of the most significant expansions in human history, crossing icy landscapes that would have seemed insurmountable without their ingenuity and resilience. Even in warmer regions, humans were not untouched by the Ice Age's reach. In Africa, where the climate was less severe, populations grew and spread, experimenting with tools and ways of living that laid the groundwork for future advancements. These groups, though not facing the frozen extremes of Europe or Siberia, were part of the same grand human story. Adapting to a world shaped by ice and shifting climates, life during the Ice Age was never easy, but it was a time of remarkable human achievement. These groups didn't simply endure the cold. They thrived in its embrace, learning, creating, and expanding the boundaries of what it meant to be human. They were explorers and artists, hunters and storytellers, leaving behind echoes of their lives in the landscapes we walk today. Their legacy is not just in the tools and art they left behind, but in the resilience and creativity that are still at the heart of our species. The Earth's shifts between glacial and interglacial periods are like the beating of a slow, ancient pulse, a rhythm that has shaped landscapes, ecosystems, and even the course of human history. But this rhythm is not steady or easily predictable. It is driven by forces both vast and subtle, interwoven into a system so complex that scientists are still unraveling its mysteries. Imagine standing on a cliff overlooking a glacier, feeling the chill of an ice-dominated world, and then fast-forwarding in time to see that same spot lush with forests and teeming with life. The stark contrast captures the question at the heart of these shifts. What causes the Earth to lurch so dramatically between these states? One of the most compelling theories begins with the Milankovitch cycles, slow changes in the Earth's orbit and axial tilt that influence how sunlight is distributed across the planet. Over tens of thousands of years, the shape of Earth's orbit around the Sun shifts from more circular to more elliptical, altering the distance and intensity of sunlight. Simultaneously, the tilt of Earth's axis fluctuates, affecting how much sunlight reaches the poles. Even the wobble of the axis, like a spinning top slowing down, plays a role. These celestial mechanics set the stage, but they are not the whole story. If they were, the transitions would be gradual and smooth. But they are anything but. The Earth's climate system amplifies these subtle orbital changes in dramatic ways. Ice sheets, for example, are both a symptom and a driver of glacial periods. When they grow, they're bright, reflective surfaces bounce sunlight back into space, cooling the planet further and encouraging even more ice growth. A feedback loop that locks the Earth into a deep freeze. Conversely, when ice begins to melt, darker surfaces of land and ocean are exposed, absorbing more heat and accelerating the warming. This push and pull between ice and sunlight creates a system on the brink of transformation, where a small nudge can trigger profound change. But the nudge itself is where the mystery deepens. Greenhouse gases like carbon dioxide and methane are key players in this story. During glacial periods, these gases are locked away in ice and deep ocean reservoirs, keeping the planet cooler. As the Earth warms due to orbital changes, these gases are released, amplifying the warming and propelling the shift into an interglacial period. This interplay suggests a delicate balance, where small changes cascade into larger ones, shaping the global climate like a chain of dominoes. Then there are the chaotic forces, volcanic eruptions, shifts in ocean currents, and the intricate dance of atmospheric patterns that can tip the scales in unexpected ways. A massive eruption could spew ash into the atmosphere, cooling the planet temporarily and slowing the onset of an interglacial. Or a change in ocean currents, like the collapse of the Atlantic meridional overturning circulation, could disrupt the heat flow between hemispheres, plunging one region into icy conditions while others warm. These theories, though compelling, remain pieces of a puzzle that is still incomplete. What makes the shift sudden, almost like flipping a switch, is a question that lingers. Perhaps it is the sheer interconnectedness of Earth systems, where a single tipping point reverberates through oceans, ice, and air. Or maybe it is the quiet chaos of a planet constantly in motion, responding to forces we only partially understand. What is clear, though, is that these shifts are not just geological curiosities. They are profound reminders of how dynamic and fragile our world truly is. The Ice Age, though far removed from written history, left deep imprints on the human psyche, shaping myths and folklore in ways that echo across cultures. These stories, passed down through generations, reflect a world where survival was a daily battle against cold, scarcity, and the unknown. They are not direct accounts of glaciers or mammoths, but poetic interpretations of the landscapes and struggles that defined human lives during and after that frozen epoch. Imagine sitting by a fire thousands of years ago, surrounded by family, as the elders weave tales that explain the powerful forces shaping their world. Stories that carry the weight of memory, fear, and awe. In many traditions, myths of great floods or endless winters may have roots in Ice Age realities. As glaciers melted and sea levels rose, ancient peoples likely witnessed dramatic changes in their surroundings. Rivers swelling, coastlines vanishing, and familiar lands disappearing beneath water. These events could have inspired legends of cataclysmic deluges, such as the story of Noah's Ark in Abrahamic traditions or the Mesopotamian epic of Gilgamesh. In Nordic mythology, the Fimbulwinter, a 3-year-long winter that precedes the end of the world, feels like an echo of the harsh conditions faced by ancestors living on the edges of Ice Age Europe. These tales capture the fragility of life in the face of a cold, unforgiving environment, blending memory with myth. In indigenous traditions across North America, where people lived alongside megafauna and witnessed their disappearance, stories often feature giant animals with supernatural traits. The Pawnee spoke of the thunder beast, a creature resembling the mammoth, while other tribes told of great hunts against massive, now extinct creatures. These stories, though layered with spiritual significance, may have been inspired by real encounters or passed down memories of a world shared with Ice Age giants. The blending of the natural and the mythical speaks to a worldview where survival was not just physical but spiritual, requiring harmony with powerful forces. Similarly, the Sami people of the Arctic wove the harshness of their environment into their cosmology. Their legends often involve icy landscapes populated by spirits and deities who control the weather and the land's fertility. These tales are not just stories but survival guides, teaching respect for the cold and strategies for enduring it. The snow and ice, ever present in their world, became characters in a larger narrative of balance and coexistence. In warmer regions, the Ice Age's influence lingered in subtler ways. In Australia, Aboriginal oral traditions recount the sinking of lands now submerged, likely memories of rising seas as the last glacial period ended. These stories, remarkably accurate in their geographic details, speak to the longevity of oral traditions as a way to preserve environmental history. They offer a glimpse of a world in transition, where ancient knowledge bridged the past and the present. These myths and folklore are more than relics of the past. They are windows into how early humans made sense of a world shaped by ice, cold, and change. They reflect the resilience of people who faced immense challenges, turning their fears and experiences into stories that could be shared, remembered, and learned from. The Ice Age may be long gone, but its memory endures, etched into the cultural fabric of humanity, reminding us of where we come from and the powerful forces that continue to shape our existence. The Ice Age has an enduring presence in popular media, a canvas for storytelling that blends the harsh realities of survival with the mystique of a world unlike anything we know today. It's a time shrouded in extremes, epic struggles against the cold, encounters with colossal creatures, and the relentless ingenuity of humans forging lives in a frozen wilderness. From animated comedies to sweeping historical epics, the Ice Age is a setting where the stakes feel immense, the challenges primal, and the triumphs deeply human. Imagine a family gathering to watch a film like Ice Age, where mammoths, sloths, and saber-toothed tigers become lovable protagonists. Though far from historically accurate, the series taps into a collective fascination with a world of megafauna and glaciers, offering a playful yet poignant glimpse into the dynamics of survival and unlikely friendships. It distills the essence of the Ice Age, a world on the edge of transformation, into a format accessible to children and adults alike, using humor and heart to bridge the vast expanse of time. On the other hand, works of fiction like Gene M. Owl's Earth's Children series dive into the human experience of the Ice Age with meticulous care and imagination. These novels reimagine the lives of early Homo sapiens and Neanderthals, exploring their relationships, beliefs, and survival strategies in a world defined by glaciers and shifting climates. Through characters who craft tools, make fire, and navigate harsh landscapes, these stories capture the ingenuity and resilience of Ice Age humans. They immerse readers in a time when survival depended on both individual resourcefulness and collective strength, highlighting how deeply rooted our humanity is in adaptation. Films like 10,000 BC take a more dramatic approach, blending history, mythology, and spectacle. While often criticized for historical inaccuracies, such movies play on the grandeur of the Ice Age, with mammoth hunts and towering glaciers serving as dramatic backdrops for tales of love, conflict, and survival. These narratives, though exaggerated, resonate because they echo the archetypal struggles of humans against nature, drawing audiences into a world where every moment feels monumental. Even science fiction and fantasy have drawn inspiration from the Ice Age. In some stories, glacial landscapes become metaphors for isolation, resilience, or untapped potential. Authors and filmmakers use the Ice Age to explore themes of transformation and survival in alien worlds or post-apocalyptic futures, drawing parallels between the challenges faced by ancient humans and those that might await us. The Ice Age also sparks curiosity about the past in documentaries and educational media. Programs like Walking with Beasts or the Ice Age Giants blend science and storytelling, reconstructing the ecosystems and creatures of the Pleistocene with vivid detail. These productions not only entertain but educate, bridging the gap between cold, hard data and the visceral wonder of imagining life in an Ice Age world. In popular media, the Ice Age becomes more than a historical period. It's a stage for exploring universal themes of survival, ingenuity, and connection. Whether through the laughter of animated animals, the grit of survival epics, or the awe of documentaries, the Ice Age invites us to imagine a world both alien and familiar, where the primal and the human intersect in ways that continue to captivate. The Ice Age lingers in the modern imagination as a symbol of endurance, a time when survival was stripped down to its rawest form and every moment was a testament to resilience. It's not just an era buried in the past. It's a mirror reflecting the fundamental human spirit, the drive to adapt, to innovate, to persevere. The harsh, frozen landscapes of that time, the towering glaciers, the relentless winds, and the looming presence of megafauna, all evoke a primal connection to what it means to fight for existence. This imagery, even if only faintly understood, colors how we think about survival and resilience today. In many ways, the Ice Age represents the ultimate trial. Imagine what it must have felt like to stand on the edge of a vast, icy expanse, armed only with tools made from stone and bone, relying on instincts and collective knowledge to navigate a world that seemed designed to test every limit. That image resonates deeply because it reminds us of the profound resourcefulness and strength our ancestors carried. Modern perceptions of survival often draw from this primal archetype. Whether in stories of explorers braving extreme conditions or in personal narratives of overcoming adversity, there's an unspoken belief that if humans could endure the Ice Age, then surely we have the capacity to overcome the challenges of today. The Ice Age also underscores the importance of community. Groups banded together to hunt, share resources, and protect each other from the elements. This sense of unity has carried into modern ideas about resilience. When people talk about facing crises, whether they're natural disasters or personal hardships, the stories that resonate most are those of communities coming together. The echoes of Ice Age collaboration still shape how we view teamwork and mutual aid as essential to surviving the harshest circumstances. Even the way we prepare for extreme conditions, disaster planning, survivalist movements, or even adventure sports, seems to borrow from the mindset forged during the Ice Age. The allure of testing oneself against the elements, of proving that you can survive in the wild, is rooted in the same instincts that guided our ancestors. It's not just about physical endurance. It's about the mental toughness to adapt to uncertainty, to face the unknown with courage. But the Ice Age's influence goes deeper than just survival tactics. It has shaped how we view resilience as a trait, not just a skill. To endure those frozen millennia was to constantly learn, to turn fear into innovation, and to see opportunity in challenge. That mindset is reflected in modern narratives about bouncing back from adversity. Whether it's recovering from a personal loss, rebuilding after a disaster, or tackling the global challenges of climate change, the underlying belief is the same. Humans are capable of remarkable resilience when they are pushed to their limits. The Ice Age may feel like an impossibly distant era, but its lessons are woven into the fabric of what we admire about ourselves as a species. It's the unspoken thread in stories of survival, the backbone of our belief in human strength and adaptability. The Ice Age wasn't just about enduring the cold. It was about proving that in the face of overwhelming odds, humanity could not only survive but find ways to thrive. That spirit continues to define how we see resilience today. The Ice Age, with its vast cycles of glaciers advancing and retreating, holds a treasure trove of lessons about Earth's climate and its complexities. Studying this ancient period has transformed our understanding of how the planet's climate system works, revealing not just the patterns of the past, but also the mechanisms driving those changes. These discoveries act as a lens through which we view the challenges of modern climate change, grounding predictions in the tangible evidence of Earth's dynamic history. It's as though the Ice Age whispers across the millennia, reminding us that climate has never been static, but has always been deeply sensitive to forces both subtle and profound. One of the most crucial insights comes from the study of ice cores, long cylinders of ice drilled from the heart of glaciers in places like Greenland and Antarctica. These cores are time capsules, preserving tiny bubbles of ancient air that tell stories of atmospheric composition during the Ice Age. By analyzing them, scientists have uncovered the intimate relationship between greenhouse gases and temperature. During glacial periods, carbon dioxide and methane levels were low, locking the planet in cold. As the Earth warmed into interglacial periods, these gases surged, amplifying the heat. This evidence underscores the role of greenhouse gases as powerful drivers of climate, a lesson that resonates with today's rising emissions and their potential to disrupt global stability. The Ice Age also revealed the concept of tipping points, moments when small changes triggered massive transformations. During periods of warming, melting ice sheets exposed darker land and ocean surfaces, which absorbed more sunlight and accelerated the thaw, a process scientists call ice albedo feedback. This cascading effect turned gradual shifts into rapid changes, reshaping ecosystems and sea levels. Understanding these feedback loops is essential in the modern context, where similar mechanisms, such as Arctic ice melt and permafrost thaw, are already amplifying human-driven climate change. The Ice Age teaches us that climate systems are interconnected and can respond to disruptions in ways that are sudden and unpredictable. Another breakthrough from Ice Age studies is the understanding of ocean circulation and its influence on global climate. The shifting of massive ice sheets disrupted currents like the Atlantic meridional overturning circulation, altering the transport of heat around the planet. These disruptions created dramatic regional differences, plunging parts of the northern hemisphere into deep cold while other areas experienced warming. This knowledge has heightened concerns about current changes in ocean currents due to melting polar ice, with potential consequences for weather patterns, fisheries, and the stability of ecosystems worldwide. The study of Ice Age sediments and fossils also paints a vivid picture of how life responds to climate change. Species adapted or migrated, while others disappeared altogether. The extinction of megafauna, tied to both climate shifts and human activity, serves as a stark reminder of how interconnected climate and ecosystems are. It's a cautionary tale for the modern era, where the rapid pace of warming threatens to outstrip the ability of species to adapt. Perhaps most profoundly, the Ice Age gives us a sense of perspective. It shows that Earth's climate can change dramatically over geological timescales, but it also highlights the unprecedented speed of current changes. Where past shifts were driven by natural forces like orbital variations, today's warming is fueled by human activity. Burning fossil fuels, deforesting landscapes, and altering the atmosphere in ways that mirror and far exceed the natural processes of the Ice Age. The Ice Age doesn't just teach us about the past, it warns us about the future. It reminds us that the climate system is delicate, dynamic, and powerful, capable of reshaping the world in ways that affect every living thing. By studying the Ice Age, we gain not just knowledge but a sense of urgency, a realization that our actions today are writing the next chapter in Earth's climate story. The Ice Age, with its relentless cycles of cold and thaw, teaches us that adaptation is not just a skill but a survival instinct deeply embedded in life itself. During this epoch, humans, animals, and ecosystems faced challenges so vast and unyielding that they redefined what it meant to endure. The lessons from that era are not just ancient history. They resonate today as humanity grapples with environmental changes of its own making. They remind us that survival depends on ingenuity, resilience, and an ability to work with, rather than against, the forces of nature. Imagine the sheer tenacity it took for Ice Age humans to carve out lives in landscapes dominated by ice sheets and tundra, where resources were scarce and the cold could kill within hours. They adapted by innovating, crafting tools from stone and bone, creating insulated clothing, and learning to hunt enormous creatures like mammoths. These weren't just acts of survival. They were acts of creativity, born from the recognition that the environment would not change to suit them. They had to change to suit it. Today, the same principle applies. As rising seas threaten coastal cities and extreme weather becomes more frequent, we're reminded that adaptation isn't about resisting change but finding ways to thrive within it. The Ice Age also highlights the importance of mobility and flexibility. As glaciers advanced and retreated, habitats shifted, forcing humans and animals to move with the changing landscape. Migration wasn't a choice. It was a necessity, a way to follow resources and escape inhospitable conditions. Modern parallels are stark. Rising temperatures and shifting rainfall patterns are already displacing communities and altering ecosystems. From the Ice Age, we learn that staying rooted in a changing world is rarely an option. Survival demands an openness to movement, to rethinking where and how we live. Collaboration was another cornerstone of survival. Ice Age humans didn't face the cold alone. They worked together, pooling knowledge and resources to overcome challenges too great for any one individual. Hunting large animals required teamwork, and sharing the bounty ensured the survival of the group. This sense of shared effort is a critical lesson for our time. As climate change affects every corner of the globe, solutions will only emerge through collective action. Communities, nations, and cultures working together to address a problem that knows no borders. The natural world during the Ice Age also teaches resilience. Ecosystems transformed repeatedly, yet life persisted, adapting to new conditions in remarkable ways. Trees colonized areas as ice receded, animals evolved to suit changing climates, and even microorganisms adapted to thrive in extremes. This adaptability is a reminder that life finds a way, but it also comes with a warning. Adaptation has limits. When change happens too quickly, as it often does now, those limits are tested and survival is no longer guaranteed. The Ice Age shows us both the capacity and the fragility of life when faced with environmental upheaval. Perhaps the most profound lesson from the Ice Age is humility. Humans during that time understood their place in the natural order. They were part of it, not masters over it. They lived in tune with the seasons, took only what they needed, and respected the resources that sustained them. In contrast, the modern world often operates as though nature is infinite and controllable. The Ice Age serves as a stark reminder that the environment is both a provider and a force to be reckoned with, one that requires our respect and careful stewardship. The Ice Age was a test of endurance, and its lessons are clear. Survival is about adaptability, resilience, and collaboration. It's about recognizing the limits of control and the power of ingenuity. As we face our own environmental challenges, the experiences of those who lived through the Ice Age remind us that while change is inevitable, thriving within it is possible. If we are willing to learn, adapt, and work together. Imagine a team of scientists standing on the vast, frozen expanse of Antarctica, drilling deep into the ice sheet. Each layer of ice they extract tells a story, carrying traces of Earth's ancient climate locked within. These scientists study ice cores, cylindrical samples of ice that preserve bubbles of ancient air. Within these bubbles are tiny relics of Earth's atmosphere from tens of thousands of years ago. By analyzing the gases, such as carbon dioxide and methane, scientists can reconstruct the temperatures and atmospheric conditions of the Ice Age, gaining a window into a world long gone. Elsewhere, paleontologists carefully sift through sediment layers, uncovering fossils of creatures that roamed the icy landscapes. Imagine holding the massive tusk of a woolly mammoth, its spiral ridges a testament to its strength and resilience. These fossils reveal not just the physical forms of Ice Age animals, but also their adaptations to extreme cold and changing environments. Studying these remains allows scientists to piece together ecosystems of the past, where now extinct predators and prey coexisted in a world dominated by glaciers. Geologists join this effort, trekking through rocky terrains shaped by ancient glaciers. They study glacial erratics, massive boulders transported and deposited by moving ice, and striations etched into bedrock by the relentless grind of glaciers. These silent witnesses to immense forces reveal the reach and retreat of ice sheets, mapping the dramatic changes in Earth's surface over thousands of years. Some scientists, like palynologists, work in quiet laboratories, analyzing pollen grains preserved in lake sediments. These microscopic particles tell tales of ancient vegetation, shifting forests, and tundras, offering clues about how plants responded to the cold and how ecosystems evolved as the climate warmed. Even the ocean plays a role in this story. Marine geologists and oceanographers collect sediment cores from the seafloor. These layers contain the shells of tiny organisms, such as foraminifera, whose chemical compositions shift with water temperature. The ocean sediments provide a timeline of changes in sea levels and temperatures, extending the narrative of the Ice Age to the depths of the Earth. What ties these efforts together is the human drive to understand. Imagine the careful excitement of a scientist analyzing isotopes, or the wonder in piecing together the tusk of a mammoth, connecting to beings that once walked this planet. These fragments, ice cores, fossils, pollen grains, and geological imprints, are the whispers of a frozen world, and through them, we hear the echoes of a time when Earth was transformed, learning lessons that resonate with our warming world today. Picture an archaeologist holding a fragment of a bone, unearthed from the frozen soil of Siberia. The question of its age lingers like a mystery waiting to be solved. Determining the age of Ice Age artifacts and fossils isn't just about technical precision. It's about connecting with the lives of creatures and humans who lived thousands, even tens of thousands, of years ago. This is where science meets human curiosity, using tools and techniques that are as much about unraveling the past as they are about storytelling. Radiocarbon dating is one of the most trusted methods, relying on the natural decay of carbon-14, an isotope found in all living things. When an organism dies, its intake of carbon stops, and the carbon-14 it contains begins to decay at a predictable rate. Researchers measure the remaining carbon-14 in organic materials like bone, wood, or plant remains. Imagine the moment when a tiny fragment of mammoth tusk or a shard of ancient charcoal is analyzed, revealing a date that places it firmly in a particular chapter of the Ice Age. It's as though the artifact whispers, "This is when I belonged." But not everything can be dated with radiocarbon. For older artifacts, or those made of stone or minerals, scientists turn to other techniques. Take, for example, a stone tool found near an ancient glacial moraine. Through optically stimulated luminescence, OSL, researchers can determine when the minerals in the stone were last exposed to sunlight. They carefully extract grains of quartz or feldspar and expose them to controlled light in a laboratory. The energy released is like a time capsule, telling them how long it's been buried in darkness. It's meticulous work, done with reverence for the artifact and its journey through time. Sometimes, the artifacts themselves aren't the direct source of information. Instead, researchers analyze the sediment layers surrounding them. These layers act like pages in a book, with each stratum representing a moment in geological history. Techniques like tephrochronology come into play here, using volcanic ash layers as markers. Imagine holding a microscope slide dusted with ash from a volcanic eruption that happened 50,000 years ago, knowing it connects to landscapes that stretched across continents. For fossils, scientists often rely on uranium series dating, especially when it comes to bones or cave deposits. This method measures the decay of uranium into thorium and calcium-rich materials. Picture a researcher in a darkened cave, shining a light on a stalactite that formed slowly over millennia. The mineral's silent growth encapsulates a timeline of environmental change, and within it lies the answer to the age of a fossilized bone embedded in its flowstone. Each of these methods is a blend of science and care, performed by researchers who see themselves as detectives of deep time. They balance precision with imagination, knowing that every artifact or fossil carries not just an age but a story. To determine when something lived, died, or was used is to reconnect with the vast web of life and transformation that defines the Ice Age, pulling its echoes into the present with every careful calculation. In the frozen expanse of Siberia, a group of researchers kneels in the permafrost, their breath visible in the icy air. They've just uncovered the preserved remains of a woolly mammoth, its body frozen in time for tens of thousands of years. The thick fur is still intact. The curved tusks are as imposing as they were when the animal roamed the Ice Age tundra, and even the contents of its stomach reveal its last meal: grasses and flowers from a prehistoric landscape. Discoveries like these are more than just scientific finds. They are intimate glimpses into a world that seems impossibly distant, yet tantalizingly close. The frozen regions of the world have become time capsules, preserving not just mammoths but a host of other creatures and clues from the Ice Age. In northern Siberia, researchers have also unearthed rhinos coated in dense fur, their massive forms hinting at a life adapted to the harshest cold. Some finds are startling in their completeness, like the Yucca mammoth, a juvenile so well preserved that its flesh could still be studied. The preservation is so extraordinary that scientists have debated the ethics and possibilities of extracting DNA, raising questions about whether such creatures could one day walk the earth again. The discoveries aren't limited to animals. In some cases, humans themselves have been found, like the mummified remains of Ice Age hunters. Tools crafted from stone and bone, left behind in frozen caves or buried in icy sediments, offer a window into how early humans adapted to the unforgiving climate. Imagine holding a spearhead shaped by hands that lived tens of thousands of years ago, its edges worn by use, but still sharp enough to tell its story. Then there are the softer, smaller details that feel astonishing in their preservation. In one case, researchers recovered a delicate Ice Age flower, perfectly frozen with its petals still vibrant. Such discoveries show not just the grandeur of Ice Age megafauna, but the fragility of the ecosystems they inhabited. Frozen soils have also yielded ancient seeds, sometimes still viable, allowing scientists to grow plants that last thrived when mammoths roamed the earth. Beneath the Arctic ice, discoveries extend to microbial life. Permafrost layers contain ancient bacteria and viruses, some of which are tens of thousands of years old. These microorganisms not only challenge our understanding of life's resilience, but also remind us of the delicate balance of ecosystems, both ancient and modern. Each discovery, from a perfectly preserved mammoth to a tiny pollen grain, feels like an encounter across time. It's not just about piecing together what life looked like, but about realizing how interconnected it all is. As the permafrost thaws, these frozen artifacts of the past are being released into the present, and with them come stories that demand our attention, of survival, adaptation, and the sweeping changes that have shaped our planet. In a quiet research lab, a scientist stares at a glowing computer screen, watching as a digital Earth from 20,000 years ago begins to take shape. Paleoclimate models are like time machines crafted from mathematics and physics, recreating Ice Age conditions to help us understand a world that no human has seen. These models aren't just numbers and equations. They're mosaics of evidence, pieced together from countless hours of research, fieldwork, and data collection. Every data point, whether from ancient ice cores, fossilized pollen, or glacial deposits, contributes to this intricate simulation of a colder, harsher Earth. Building these models starts with data from the physical world. Ice cores drilled from Antarctica and Greenland carry a record of the past in their frozen layers, each containing tiny air bubbles that preserve snapshots of the ancient atmosphere. Scientists extract information about greenhouse gas concentrations and temperatures, using these details to establish the boundary conditions of the Ice Age world. From the sediment cores of the deep ocean, they retrieve chemical signatures of water temperatures and currents, adding more layers to the picture. It's not just data. It's a story being pieced together, layer by layer, whispering of vast ice sheets and frozen seas. As the data is fed into models, scientists use equations rooted in physics to simulate how energy and matter flowed through the Earth systems. Imagine programming the interactions between the atmosphere, oceans, ice sheets, and vegetation, each responding dynamically to changes in temperature and sunlight. It's not unlike trying to choreograph a dance between forces as vast as the jet stream and as fragile as Arctic moss. Every calculation builds on the last, revealing patterns of wind, precipitation, and temperature that defined Ice Age climates. One of the most fascinating parts of these models is the interplay between the Earth's orbit and its climate. Subtle shifts in the tilt, wobble, and shape of our planet's orbit, known as Milankovitch cycles, control the distribution of sunlight across the globe. By inputting these orbital parameters into the models, scientists can observe how glaciers advanced and retreated, how deserts expanded, and how the Earth cooled and warmed over tens of thousands of years. It's humbling to think how such small cosmic shifts could shape entire epochs of life on Earth. The models are then tested against the evidence, and this is where the human element shines. Researchers compare the simulated climate patterns with the actual fossil record, such as pollen from ancient plants or isotopes in cave stalactites. When the models accurately reproduce known ice age conditions, like the extent of the Laurentide ice sheet or the cooling of the tropics, it's a moment of validation, a realization that they've glimpsed the past with remarkable clarity. But these models aren't just tools for understanding history. They help scientists project how our planet might respond to future climate changes. By studying the Ice Age, a time of dramatic shifts in climate and ecosystems, they gain insight into how Earth's systems might behave in a warming world. Each simulation isn't just a recreation of the past. It's a way to connect that ancient, frozen world with the challenges of today, bridging the gap between what was and what could be. A research team stands on the windswept plains of Yukon, brushing away soil to reveal an ancient caribou antler. Nearby, a layer of sediment holds tiny grains of volcanic ash, each tied to a specific eruption thousands of miles away. These kinds of recent discoveries have brought the Ice Age into sharper focus, revealing not just its grand, frozen landscapes, but the intricate web of life and change that defined it. Advances in technology and fresh finds from around the globe are filling gaps in our understanding, turning a hazy narrative into something vivid and immediate. One of the most groundbreaking revelations comes from the world of genetics. With advances in DNA extraction and sequencing, scientists are decoding the genetic blueprints of Ice Age species from bones and teeth preserved in permafrost. Recently, they sequenced the oldest DNA ever recovered, from mammoths that lived over 1 million years ago. This genetic material tells stories not only of individual animals, but of entire populations, showing how species like the woolly mammoth and steppe bison adapted to shifting climates and moved across continents. These discoveries don't just bring the animals to life. They connect them to their modern descendants, linking the Ice Age directly to today. In Greenland, scientists drilling through ancient ice layers made an astonishing find: sediments trapped beneath the ice sheet, dating back more than 1 million years. These sediments revealed that Greenland was once free of ice, with lush forests and flowing rivers, a reminder of how dramatically the Earth's climate has transformed. Such discoveries help scientists refine their understanding of ice sheet dynamics, offering clues about how quickly glaciers can grow or melt, insights that are crucial in the face of modern climate change. Another recent breakthrough comes from the seafloor, where marine sediment cores have provided detailed records of Ice Age ocean currents. These currents played a vital role in regulating global climate, distributing heat and nutrients around the planet. Researchers have discovered evidence of abrupt shifts in these currents, events that triggered rapid climate changes during the Ice Age. Understanding these tipping points has shed light on how interconnected the Earth's systems are, from the oceans to the atmosphere. Even human history has been reshaped by new Ice Age discoveries. In Denisova Cave in Siberia, scientists uncovered tiny fragments of bone and teeth belonging to a mysterious group of humans called Denisovans. These ancient relatives of modern humans lived alongside Neanderthals and Homo sapiens, and their DNA, found in people living today, hints at migrations and interactions that span continents. Tools and art discovered in the same regions suggest that Ice Age humans were far more resourceful and creative than previously thought, thriving in environments that seem almost unimaginable to us now. Each discovery, whether it's a perfectly preserved Ice Age wolf pup in Yukon or a pollen grain buried deep in Antarctic ice, adds a piece to the puzzle. Together, they reveal a world that was dynamic and interconnected, full of challenges but also resilience. These finds remind us that the Ice Age wasn't just a frozen chapter in Earth's history. It was a time of profound change, innovation, and survival, and its echoes continue to shape the way we understand the planet today. A scientist gazes at a series of graphs on a computer screen, each line representing fluctuations in Earth's climate over hundreds of thousands of years. The patterns are unmistakable. Periods of warmth, like the one we're in now, followed by plunges into icy epochs lasting tens of thousands of years. These cycles, driven by subtle changes in Earth's orbit, have defined our planet's climate for millions of years. But the question of whether another ice age could occur anytime soon is no longer just about natural rhythms. It's about how human activity has altered the rules of the game. If we look at the natural progression, Earth should eventually cool again. The cycles of glaciation, triggered by changes in Earth's tilt, orbit, and wobble, suggest that in tens of thousands of years, ice sheets could once again begin their slow creep across the continents. In fact, before the Industrial Revolution, some scientists believe the planet might have already been on a slow path toward cooling. But the sheer volume of greenhouse gases humans have pumped into the atmosphere has disrupted this balance. Carbon dioxide levels today are higher than they've been in millions of years, trapping heat and delaying, or perhaps completely preventing, the onset of the next ice age. It's a strange paradox. While the idea of an ice age might seem terrifying, massive glaciers grinding across North America, Europe, and Asia, it also represents a natural reset in the Earth's climate system. These cooling periods have historically lowered sea levels, exposed land bridges, and created opportunities for species to adapt, migrate, and evolve. Yet the warming we've caused might have closed that chapter indefinitely, keeping the Earth locked in a prolonged interglacial period. There's also a more speculative, chilling possibility. If something disrupted global ocean currents, such as a massive influx of fresh water from melting ice sheets, it could theoretically trigger localized cooling even as the planet as a whole continues to warm. This scenario is often depicted in apocalyptic terms. A sudden and severe drop in temperatures in regions like Europe, driven by the collapse of the Atlantic meridional overturning circulation. While such an event wouldn't create a true ice age, it's a stark reminder of how fragile Earth systems are when pushed beyond their limits. But the bigger truth is that we're no longer just observers of the planet's cycles. We've become a force shaping the trajectory of Earth's climate, steering it away from the paths it might naturally take. Another ice age, if it were possible, might be tens of thousands of years in the future. But what happens in the meantime? The warming, the rising seas, the changes to ecosystems will define the story of our time. As the scientist turns away from the graphs, the questions remain. What does it mean to live in an age where we've overridden natural cycles? Could we ever return to a balance where something like an ice age is even possible? The answers lie not just in data or models, but in how humanity chooses to act, knowing that we hold the power to shape the planet's future in ways once governed only by the vast rhythms of time. The first signs would be subtle. A slight cooling in global temperatures, more persistent winters, and glaciers slowly beginning to reclaim their hold on high mountain valleys. Scientists and governments would likely be the first to notice, poring over climate models and issuing warnings. Imagine the urgency as news spreads. Earth is entering a new ice age. For humanity, the question wouldn't just be one of survival, but of adaptation and ingenuity. How would we reshape civilization to endure a colder, harsher world? Cities in northern latitudes would face the most immediate challenges. Metropolises like Moscow, Stockholm, and Chicago, already accustomed to cold winters, would confront longer and more severe freezes. Crops that thrived in temperate climates, wheat, corn, and rice, might falter, leading to widespread food shortages. Coastal regions, ironically, might find some relief at first. Falling temperatures could lower sea levels as water is locked in expanding ice sheets. But the reprieve would be temporary, as harsher winters and dwindling resources put immense pressure on populations to migrate. Mass migrations would likely become a defining feature of life during an ice age. Just as early humans moved southward during past glacial periods, modern civilization might see a similar shift. Warmer regions, equatorial countries, and southern hemispheric continents would become havens, their climates more stable and capable of sustaining agriculture. The challenge, however, would lie in managing the influx of billions of people. Border policies, infrastructure, and resources would strain under the pressure of these migrations, forcing nations to cooperate or risk widespread conflict. Technology would become humanity's greatest ally. Advances in renewable energy, insulation, and heating systems could mitigate the cold, while vertical farming and hydroponics might ensure food security in areas where traditional agriculture collapses. Scientists would likely attempt geoengineering projects on an unprecedented scale, aiming to stabilize the climate by manipulating atmospheric conditions. Imagine massive projects to release aerosols into the upper atmosphere to trap heat or constructing sprawling underground cities designed to shield populations from the relentless cold. Society itself would transform, shaped by the necessity of survival. Economies would shift toward resilience, prioritizing resource distribution and sustainable practices. Community structures might grow stronger, with cooperation becoming essential to weather the crisis. At the same time, inequities could deepen as wealthier nations and individuals secure their survival, leaving vulnerable populations to face the brunt of the cold. The human spirit, however, has always thrived under adversity. Just as our ancestors created tools, built shelters, and formed networks during the last ice age, modern humans would innovate, finding ways to not only endure but thrive. The arts, too, would reflect this frozen era, capturing the stark beauty of a snow-covered world and the resilience of humanity. Stories of survival, ingenuity, and connection would become cultural touchstones, reminding future generations of how civilization faced one of nature's greatest challenges. Coping with a new ice age wouldn't just be a test of science or infrastructure. It would be a test of humanity's ability to adapt, to come together, and to find hope even in the coldest of times. The thought of a new ice age emerging in modern times feels like an idea plucked from science fiction, but the Earth's history reminds us that it's not entirely impossible. Triggers for such a dramatic climate shift, while unlikely in the near future, aren't beyond the realm of natural or human-caused events. The forces behind an ice age are intricate, interwoven with the rhythms of our planet. Yet they also leave room for sudden disruptions that could push the climate in an unexpected direction. To imagine such a scenario is to stand at the crossroads of science, nature, and human influence. One potential trigger lies in the cosmic dance of Earth's orbit. The slow, subtle changes in our planet's tilt, wobble, and orbital shape, known as Milankovitch cycles, have historically driven the advance and retreat of ice sheets. These cycles determine how much sunlight reaches different parts of the Earth, and in the past, they've set the stage for glaciation. However, in our current era, the natural cooling associated with these cycles has been overwhelmed by the warming caused by human activities. Still, in theory, if greenhouse gas levels were somehow reduced, whether through massive natural absorption or a deliberate human effort, the Earth might return to a cooling trajectory aligned with these orbital changes. Another possibility comes from disruptions to the ocean circulation. The planet's vast ocean currents, such as the Atlantic Meridional Overturning Circulation (AMOC), act like conveyor belts, moving warm water from the tropics to the poles and returning colder water southward. If these currents were to weaken or collapse, it could cause dramatic cooling in some regions, especially in the northern hemisphere. This kind of disruption could be triggered by an influx of fresh water into the oceans, perhaps from melting polar ice or massive glacial runoff. Such a scenario would mirror past events like the Younger Dryas, a sudden cold period that interrupted the Earth's warming after the last ice age. Volcanic activity could also play a role. Imagine a massive eruption spewing ash and sulfur dioxide into the atmosphere, blocking sunlight and causing a sharp drop in temperatures worldwide. While such an event wouldn't directly trigger a full-scale ice age, repeated or sustained volcanic activity could create conditions favorable for prolonged cooling. A volcanic winter on a large enough scale could tip the delicate balance of the Earth's climate, especially if combined with other factors. Human intervention, whether intentional or accidental, could also be a wild card. Geoengineering projects designed to counteract global warming, like injecting aerosols into the stratosphere to reflect sunlight, might have unintended consequences. While the goal would be to cool the planet, overzealous efforts or unforeseen feedback loops could push temperatures too low, creating conditions that mimic the onset of glaciation. Similarly, massive reductions in greenhouse gas emissions, if achieved too abruptly, could theoretically allow natural cooling cycles to regain dominance. Asteroid impacts, though exceedingly rare, present another dramatic possibility. A collision large enough to throw dust and debris into the atmosphere would plunge the Earth into darkness and cold, creating a catastrophic freeze. Such an event would likely devastate ecosystems and set off a chain reaction of climate shifts that could spiral into an ice age. In modern times, the interplay between human influence and natural forces makes the idea of an ice age far more complex than it was in the past. While the Earth has its natural rhythms, our actions have become an undeniable factor in shaping its climate. If a new ice age were to be triggered, it would likely arise from a combination of these forces, each amplifying the other in ways we are only beginning to understand. To contemplate such a future is to recognize the fragility of the balance that sustains our current climate and the profound responsibility we hold in maintaining it. The planet is warming, glaciers are retreating, and sea levels are rising. But hidden within this story of heat is a quieter question about cold. Global warming, driven by human activity, isn't just reshaping the climate we experience today. It's also rewriting the Earth's long-term future, including the cycles that have given rise to ice ages for millions of years. To understand how our warming world influences the likelihood of future ice ages, we have to explore the delicate interplay between natural rhythms and human impact, a balance that we've tilted in ways our ancestors could never have imagined. For most of Earth's history, ice ages have followed a predictable pattern, triggered by slow changes in the planet's orbit, tilt, and wobble. What scientists call Milankovitch cycles. These subtle shifts determine how much sunlight different parts of the Earth receive, and over tens of thousands of years, they've driven the advance and retreat of massive ice sheets. However, these natural cycles rely on a fragile equilibrium, where cooling processes gradually outweigh warming ones. Today, that balance has been disrupted. The greenhouse gases we've released, carbon dioxide, methane, and others, are trapping heat in the atmosphere, overwhelming the cooling effects that might otherwise have begun nudging the Earth toward another glacial period. Before the Industrial Revolution, the Earth might have been on the cusp of a slow cooling trend, one that could eventually have led to another ice age in tens of thousands of years. But current levels of atmospheric carbon dioxide, now higher than at any point in at least 3 million years, have effectively put that process on pause. The heat trapped by these gases not only prevents global temperatures from dropping, but also melts ice sheets and raises sea levels, further altering the planet's energy balance. It's as though the Earth's natural thermostat has been overridden, set to a state that defies its ancient patterns. There's another layer to consider: the oceans. Global warming is already affecting major ocean currents, like the Atlantic Meridional Overturning Circulation, AMOC, which plays a crucial role in distributing heat around the planet. If these currents were to slow significantly or collapse due to melting polar ice and an influx of fresh water, it could trigger localized cooling in the northern hemisphere. But even this wouldn't lead to a true ice age. It would be a regional phenomenon, overshadowed by the broader warming trend that defines our time. What's striking is that even if humanity were to drastically reduce greenhouse gas emissions, the legacy of our actions would linger for thousands of years. The sheer volume of carbon dioxide in the atmosphere means that cooling processes would take an incredibly long time to reassert themselves, delaying the natural cycles that might have once led to glaciation. In effect, we've created a world where the likelihood of a future ice age has become vanishingly small, replaced instead by the challenges of managing a warming planet. It's a sobering realization. The very forces that have shaped life on Earth for millions of years, glacial cycles, rising and falling seas, expanding and retreating ecosystems, have been fundamentally altered. The story of the Ice Age has always been one of change and adaptation, but now that story intersects with our own. The question isn't just whether another Ice Age will happen, but what kind of planet we will leave behind, not only for ourselves but for the distant future. A world shaped as much by human hands as by the slow, patient rhythms of nature. As the first flurries of snow begin to fall longer and heavier, and glaciers creep ever so slowly into once temperate lands, humanity would find itself at a crossroads. The prospect of another ice age is no longer an abstract question of geology or paleoclimate. It's a test of survival, ingenuity, and the technologies we've spent centuries perfecting. To endure such a shift would require not just grit but innovation on a scale never seen before, blending ancient instincts with cutting-edge solutions. Heating would become a matter of life and death, not just for comfort but for survival. The modern world relies on centralized energy systems, but in an ice age, these might falter under the strain of freezing infrastructure and disrupted supply chains. Renewable energy would take center stage, with solar panels and wind turbines adapted for cold climates. Advanced geothermal systems, drawing heat from beneath the Earth's surface, could provide stable and sustainable warmth even as temperatures plummet. Innovations in energy storage, like next-generation batteries and thermal storage solutions, would ensure power even during prolonged winters when sunlight is scarce. Food production would face extraordinary challenges as traditional farming collapses under layers of snow and frozen soil. Vertical farming, already a growing field, would likely become humanity's primary means of agriculture. Skyscrapers in urban centers could be converted into climate-controlled farms, where crops are grown hydroponically under LED lights tailored to mimic sunlight. These systems would require significant energy, but could produce food year-round, independent of the harsh conditions outside. Genetic engineering would also play a role, creating frost-resistant crops capable of thriving in the cold or adapting livestock to survive in extreme environments. Shelter would need to evolve. Modern buildings, designed for temperate climates, would struggle to retain heat in an ice age. Insulation technologies, possibly using materials like aerogels, would transform homes into thermal fortresses, conserving energy while protecting inhabitants from the elements. Entire cities might move underground, where geothermal warmth provides a buffer against the cold above. These subterranean metropolises would function as hubs of activity, blending living spaces with agriculture, industry, and governance in enclosed, self-sustaining systems. Transportation would face its own hurdles. Snow and ice would render many traditional routes impassable, requiring vehicles that can navigate treacherous conditions. All-terrain electric vehicles, equipped with advanced battery systems and designed for cold performance, could become the norm. For longer distances, hyperloop networks or maglev trains, running through insulated and heated tunnels, might connect key population centers. Drones and automated systems could handle supply chains, delivering essentials across frozen landscapes. Geoengineering, though controversial, might become humanity's boldest tool for managing an ice age. Technologies to manipulate the atmosphere, such as deploying reflective aerosols to balance global temperatures, or even attempting to artificially warm localized regions, could be considered. While the risks of unintended consequences would be high, the need to stave off extreme cold might drive researchers to push these boundaries. Communication and data technologies would be critical, allowing isolated communities to stay connected and informed. Satellites designed to withstand extreme conditions could facilitate global coordination, ensuring that no one is left behind. Artificial intelligence would play a role in managing resources, optimizing energy use, and predicting weather patterns in this new, volatile climate. Humanity's ability to survive an ice age wouldn't just rely on technology. It would depend on how we use it. The strength of our networks, the resilience of our systems, and our capacity for cooperation would determine whether these tools succeed. In this frozen world, innovation would thrive not just out of necessity, but because of our unyielding drive to adapt, proving once again that even in the harshest conditions, we are capable of creating warmth, sustenance, and hope. And so, we come to the end of our journey through the frozen echoes of the Great Ice Age, a time when the Earth itself seemed to hold its breath under miles of ice, and life danced on the edge of survival. If you've made it this far, thank you for sticking with us as we unravel the mysteries of this ancient world. From the colossal forces that shaped it to the remarkable creatures and humans who called it home. It's amazing to think how much of our modern world was shaped by those icy millennia, isn't it? If you enjoyed exploring this frosty chapter of Earth's history with us, don't let this conversation go extinct. Hit that like button and leave a comment with your favorite Ice Age fact or question. And if you're craving more journeys into the unknown, make sure to subscribe to Quiet Universe and join our growing community of wanderers who can't stop asking, what if? Until next time, stay curious, stay warm, and as always, thanks for watching. See you in the next one.